Good morning, ladies and gentlemen, and welcome to the second day of the Estonian Wind Energy Conference. I hope you all had fun yesterday. The reception was quite something. Unfortunately, I had to leave early, but looking at your smiling faces, I'm confident that you took the maximum of it. Now, we're going to look into greater detail topics that we already started with yesterday. We're going to hear from the Estonian government plans on how to improve the accessibility to the grid. What are their plans with the auctions? We're also going to look at technology that actually makes sense when you have a lot of energy in your hands, among others, hydrogen. But we're going to start with the Dutch experience. Now, the Netherlands clearly have very ambitious plans for offshore wind energy. As we already heard from the ambassador yesterday, by 2030, the Dutch government aims to have 21 gigawatts of offshore wind capacity. Now, the targets further escalate to 50 gigawatts by 2040, and with a long-term goal of achieving 70 gigawatts by the mid-century. That certainly sounds ambitious. And looking at the Dutch track record, I have little doubt that they will actually be able to pull this off. Now, why are they doing that? Where have they stumbled in the past? What can we learn from their mistakes, but also their ambition? This is what the first session is all about. And I'm honored to invite onto the stage for the opening words of this session, Eero van der Broek, project initiator linked by offshore wind, Baltic states. The floor is yours.
Thank you very much. Thank you very much, and I will keep it very short, but just a short introduction. My name is Eero van der Burg, coordinator of Linked by Offshore Wind, and I have a bit of the feeling that I'm starting with the end, because the beginning was actually yesterday. The most important element for us was the matchmaking that we had on the corridor yesterday afternoon, and many of you participated in that. And that's basically the core of what we do. That's matchmaking, bringing the companies from the Netherlands to the Baltic states, understanding what the Dutch companies want, understanding what Estonia and the Baltic states want, what the level of development is here in the Baltic states, what the individual companies here want, and making that individual click. And we think that by knowing what the Dutch companies want, what the market here wants, that's the best key for success. Linked by Offshore Wind, public-private partnership between the Dutch government and the private sector in the Netherlands. We have 13 companies that are member of this cluster of companies, and we brought over the past few days our friends with us as well. And so we're here with 22 companies and 30 people in total. Standing on the shoulders of giants, that's what this famous saying. So building on what the embassy has already been done over the past years, and the connection that have been laid here already. So that's really very helpful, and will help us bring together the cooperation between the Netherlands and the Baltic states and Estonia specifically further. That gives you a bit of an introduction what we're here doing. It gives you a little bit of the background of who we are after the fact. That we had already this most important event for us, the matchmaking, yesterday. I would like to give the floor now to Edwin van der Brug, who will further introduce the session and the Dutch companies. Thank you very much.
Whoa, that's a lot of light. It's a bit stupid to have 3 introductions for one session, but okay. I'll try to give it a go. Two things to look at. Yes, the Dutch are arrogant and of course want to show their knowledge and tell you everything they've done. But essentially, if you compare where the Baltic countries are and where the Dutch are, if you look at the Baltic countries at first, Lithuania is now more or less stepping into offshore wind. I was there 3 weeks ago, and they are really preparing to start building a project in a while. They do soil investigation. They look at supply chain. That's the reason I was there. And they want to build in a couple of years from now. If you look at Latvia, they were thinking last year, and I think they're still thinking this year, and they could be thinking a bit longer. And maybe something beautiful pops out. Indra is somewhere over here. There you are. Maybe you can inform us all about Latvia later on. And if you look at Estonia, you're in the in-between phase. You're not building already. You're not thinking about the policies. There are, or you are still thinking a bit about the policies, but there are a number of developers really stepping up into the game. There are a number of developers who do environmental impact assessments, who have to start with environmental impact assessments, who are looking for partners to take the next steps because they need finance and experience. So it's in between. And I think what we hope to do here in this first session is to show where some of these Dutch companies can add value exactly in this part of the development. And then going back to the experience they have. Because if you compare to the Dutch, Johannes said it, morning Islam, the ambassador said it, we have success stories, but we also have a huge pile of non-success stories so hidden behind the curtains. If you ask RVO or the Dutch ministry, they will tell you that we had a beautiful 2023 roadmap and that we had a celebration on it last year. But they every now and then forget that the first 10 years was a kind of puzzle. It was a kind of clumsy way of getting into offshore wind. And that's also what we don't want to hide, because most probably what we did do wrong are the best lessons learned where you can go proceed on. Having said so, third introduction, and now it's time to give the floor to the 4 companies. And I totally forgot who's going to start.
Jan.
Thank you. At least Johannes is awake and taking over the lead. Gert-Jan, the floor is yours.
Thank you. Hello, good morning, everyone. I'll start, see if this works. Yes, it works. My name is Gert-Jan Jopse. I'm a renewable energy consultant at Pondera, and I'm here to share some of the experience, some of the lessons learned, the clumsy years and the success years in Netherlands. And I'm doing this for the development of Estonian wind energy. That the focus will be on offshore energy, but I think many of these lessons also apply for onshore. And since today is the 14th of February, I thought, let's talk about friendship, a few things. And I've combined these 2 maps, and I just realized that actually Estonia is bigger than Netherlands when it comes to the land surface. It's about 92%, if I'm correct. The actual sea area of Netherlands is bigger. That's because the North Sea is bigger than the share of the Baltic, the slice of the pie, so to say. And what's also interesting is that your coastline in Estonia is so much longer than the smooth, curved coastline in Netherlands. And that's because of all the islands and the beautiful archipelago. Population, I think it's 10 or 30 times, so there's more space, so to say, and good company. So let's celebrate Friends Day. And friends are not just there to share successes. We should celebrate that, of course, but also to share failures and clumsiness, as everyone already said. So you may have heard in the news that last year Netherlands has exceeded its target that they set in the roadmap for themselves by a few 100 megawatts. But there was a long road to get there. I'll share some of the experience of Pondera. That's the company I work for. We are focused on renewable energy, so that's production, solar, wind. That's transport, mostly cables. That's conversion and storage. And we want to be at the forefront of developments, and I think the industry has to be. So teamwork is really essential, innovative solutions, and I'll share a few things about it. New horizons in renewable energy. This is a long list. I won't go through that in detail, but it's important to remember that offshore wind development and any wind development is a process, and it has separate steps. It starts with the early phase in development, so the actual planning stage, what are we going to do, where and how. Then it comes to due diligence, it comes to what are actually the wind resources available, it comes to modeling, it comes to layout. Very important is the formal process of the EIA and the permitting process. That's where actually technology meets the environment and society, and that process is quite central and distinct for the time. When it comes to the next phase, it depends a little bit how it's organized in each country, but tender management often comes to the picture as an important way to actually make a storyline, an integrated story of how you're going to approach the wind field. In the Netherlands, in the case of the Netherlands, a winning bid. We're also involved in project delivery, both in terms of contract, construction management, owners engineering, and key personnel work supervision. So through the different stages involved in wind. I think I'll skip this one. This shows is a lot of small projects or some small dots with large projects behind. It shows actually how much is going on in Netherlands part of the North Sea, and of course the other countries are in it as well. Come back to the numbers. The numbers itself are numbers, but there's a story behind, and the story in Netherlands has been set, as you have heard, in the roadmap. So there was a target. We were well on our way, but it took a long time to get there. The numbers also tell us that about 16% of electricity generated is installed now, so it's well on the way. Often not shown is the number of kilometers that it actually takes to get the energy onshore. So talking about offshore energy, grid and transport is really crucial. And you have seen this map probably before. It shows the ambitions. There's high ambitions for 2030, outlined in the roadmap that was drafted about 10 years ago, and we're now in the third revision of that roadmap. I won't go through the numbers again, but do remember that this is one step in a process. So the cake of the pie of the North Sea is already under study for the further 2050 target of 72 gigawatts. So I personally like this map more because it actually shows the transport infrastructure that's required to take all that energy produced onshore. And I don't know if it's visible on the screen, but you can see a lot of long lines, and it also shows some of the complexities having the big cities in the center of Netherlands, Amsterdam, Rotterdam, with very little access to the grid that has led to very long transport lines. And that's one of the lessons, I think, to consider, that in a society you have to make choices, and these choices, for different reasons, may result in what seems perhaps not the most optimal solutions until you dig deeper into that. So let's dig a little bit deeper into the key drivers. It's about collaboration, it's about the investment climate, it's about the industry, and it's about the grid. So I'll talk more about that. It's about the tender system also. You've heard about the auctions and how they are organized, and the importance of innovations and modeling in different phases of the projects. Essentially, it's about de-risking projects. So in order to get your project realized on time, on budget, and with the desired energy generation, there's many risks on the way. There's impacts, there's risks that you want to manage, both from a society perspective, but also from a business perspective as a project manager or developer. And it starts with a very clear marine spatial plan. So what are actually the areas, what is possible, how to avoid conflicts. So, and if there any conflicts arise, you need to solve them in an early stage, because later on you want to avoid court cases or sectors suffering and being on the way. So one of the some of the fields you may come across, fisheries, obviously ecology, shipping lanes. So the sea is not an empty sheet. There's many sectors and economic interest and environmental values. And the third risk important is solve the grid connection in an early stage. So think about what if we would come across, perhaps for now or for later, certain impacts that we try to avoid. What are all the alternative ways to get the electricity onshore? So these need to be solved in an early stage. Yesterday we heard about banking. I'd like to remind also that offshore wind and wind are considered by the IFC as category A projects, so projects with a considerable impact on the environment and social and government impacts. So ESG in an early stage, and luckily in Europe we have the EIA directive to assess in an early and in a reliable way the different impacts. And finally, in different stages, use advanced modeling to optimize the layout and really benefit from what you install. Here's an example of those cable infrastructures. It's IJmuiden-Ver. Those are the 2024 auctions that are 3 times 2 gigawatts DC. So different cables that take a very long route. And yeah, I think you can see it on the map that it's not the straight line to the coast. It's actually indeed a very long way towards the harbors of Rotterdam and the grid connections in Flushings in Zealand. So these are very long corridors that do not perhaps seem the most logical way, but they are the outcome of an integrated assessment. Pondera has also been drafting, together with Arcadis, the environmental impact assessment, and we have done different analyses and studies, including the permit applications. There's another thing that was mentioned as one of the key drivers, and that's standardization. So it's a relatively unnoticed, perhaps boring topic, but very essential to cost reduction and certainty of delivery. And there's 2 aspects, 2 examples I'd like to show. That's the 700 megawatt substation offshore, those yellow cubes. In the initial drafts, they were not yellow, but they had to be yellow because they were on the sea, and they are quite big, so you don't want to hit them in a storm. So they are clearly visible. But this actually box of advanced technology is really essential in cost reduction, because many of them could be built in an efficient manner and also increases reliability of the net. Second, last year, the North Sea Standard was presented. That's a proposal from the Netherlands Wind Energy Association to have a 1,000 feet, that's where planes are allowed to fly, 1,000 feet wind turbine, have a kind of minimum installed capacity of 40 megawatt per foundations, and this will apply for the tenders as of today, and will be evaluated in 10 years' time. So economies of scale and also delivery, and also avoiding ending up in a kind of rat race of ever-increasing sizes of large wind turbines. I mentioned now tender management, or the tendering process, a couple of times, and I realized the process in Estonia and the Baltic states may be different, but there are some takeaways from it, that in Netherlands fully permitted sites are tendered. That also includes permits for hydrogen and floating. But what is essential to these tenders is not just about the financial bit. It's really about different point-based points being evaluated against each other, and really about promoting system integration, promoting delivery, so early certainty of delivery, and ecological innovations that are part of this tender process, sometimes up to 50 or 75% of the scores to win the actual auction. And that leads to innovation. And we can actually see that when there's a possibility to include hydrogen, or when there's a chance to actually improve environmental or ecological conditions, that's already taking place. And it leads to innovations in the sectors. So developers or bidders really have to do their best to think of ways to enhance biodiversity on their site. And I believe it's also going to work, because these artificial reefs that we are creating in the otherwise quite sandy and a bit flat North Sea are really attracting a lot of plants and animals. There's another innovation I'd like to mention, and that is the importance of data, the importance of modeling. And as you know, the traditional offshore wind measurements are quite expensive. It's very expensive to put a measuring device or a mast offshore, but actually a combination of onshore wind measurements together with advanced modeling using high-resolution meteorological data really leads to a better insights into wind resources, and also thus to better modeling for actually layout optimization. And this may sound a bit difficult, but if you look at it, that actually the grid resolution is really so much more dense than it used to be. You can understand that it actually leads to better understanding of, for example, Vogue effects, so the effect that the wind turbines have on each other in terms of turbulence. So as a takeaway, it's the GRASP, that's the methodology used, can help reduce the costs in the development stage of a project. A more detailed modeling helps you to better understand the wind conditions and the wind resources. So we've now talked about, I've now presented different ways of the importance of the grid, the importance of the tendering process, the added value that wind offshore projects can have, for example, for biodiversity. Let's look at the lessons learned in wind energy that we can share with you as friends today on this Valentine's Day. First of all, it's to provide certainty. It's certainty for the sector, for the market, but also to the public. So when you know what's actually going to happen, you can prepare for that. And as you probably know, that wind energy development is not a sprint. It is actually a marathon, or perhaps a triathlon, with different disciplines, with long lead times, it's complex, so it really requires an effort and a long breath. Second, I'd like to share is that it's really important to delve into the specifics of the site. We cannot assume the sea is just a blank granite rock or a sandy beach. It's really much more complex. And it's good in an early stage, even though there are often higher costs involved, but to really understand the site very well, to go to the site and study it in detail so that you know what to expect. And when you know that, you actually know how to mitigate impacts on environment, on society. That's about governments, really. And nowadays, we're also thinking of ways to enhance nature, as the sea is not has so much potential and so much life. That is something, and I think this applies to the North Sea, but also to the Baltics, the Baltic Sea, that there's so much life we can generate, and that can be something that wind turbines, wind farms can actually add. Tender management is a way for winning bids, and again, the non-price criteria help to really add value, not just financial value, but also security for the system, and enhance other values. Then the importance of standards for cost reduction, economies of scale, and for deliveries. That really applies to Europe and perhaps to the world, that of course we can keep on improving and increasing the size of wind turbines, but really advanced technologies and standards are already in place. And in the next foreseeable future, we can estimate what is going to come. Of course, there will be new ones after 10 years, but this is an important takeaway. Take advantage of the innovations in data and modeling, and finally, the power of collaboration. That's why we are here. And together we can push for new frontiers in energy production, in energy transport, in storage, and in conversion. So thank you for your attention.
Thank you very much. Excellent. We will get into greater detail in the panel that is about to follow, but before we get there, I'm pleased to invite onto the stage Roland Borsboom, who is the project director at Ventolines. They recently won a public tender to consult the team behind the Estonian-Latvian cross-border offshore wind project Elwind, so excited to hear what they have for us.
Thank you. Good morning. First introduction, my name is Roland Borsboom, and for all my sins I've worked in oil and gas for 30 years, so here's the confession. But I've seen the light in the end, so my last job at Shell as an oil major was doing the 700 megawatt offshore wind farm for Borssele 3 and 4. And I think one of the themes, if I sort of build onto what Gert-Jan was saying, Gert-Jan looked a lot at the outside ecosystem, and as Edwin asked us to look at the various stages, I zoom a little bit more into the development process itself. And I'll talk about that in a minute. Before we do that, let's see if this works. It does. Although Edwin said no advertising, there will be a little bit of advertising for Ventolines, but not too much. Essentially started as a company, very Dutch, very Netherlands, onshore wind, offshore wind, solar. And I think the themes that we are looking at is diversification and internationalization. Diversification in the sense that we now have between, well, more than 5 and less than 10 large-scale battery projects in development, one going into financial close this year. And we are going international. We've done work in Sweden, Australia, Americas, and now also in the Baltics. So we're spreading our wings international. This is about some of the characteristics of what we do, but to keep the advertising short, this can be read in afterwards. We're about 100 people. I think I learned in the bus this morning a very similar size to Pondera. so there you go. So sometimes we compete and sometimes we collaborate and we meet. And I think in the end, this industry, and that's something that Gert-Jan already said, needs a lot of the collaboration. There is so much work for everybody. We better join forces. We are working as an owner's engineer. What I mean with that is we start at the early permitting and we also operate the assets we actually build ourselves. So we're right from the beginning until the 30 years of operation. And that means that you have to operate your own errors. So you better get it right, because otherwise you're managing the own stuff you did wrong in the phase before. I think that does make it a very broad and interesting employer to work with, and it's also then sort of a rich background that we offer if we want to support our clients. That's what we're doing today. Before we go there, I was for the first time in my life in the Baltics last April, organized by a trade mission from the Dutch Economic Affairs, RVO, and Partners in Business, or is that PIB? Almost right. And actually, I'm proud to say that the trade mission also resulted in some trade. So it was already mentioned, we do some work for Elwind. I have to add that we do this not on our own, but together with L4, a local Latvian party, and ERM, an international environmental consultancy. And what we do is actually that the Elwind project itself, of course, you know, what we do is we provide specifications for the tenders that will be run by the Elwind project themselves in the market to do the front-end data work. And I think when we were talking to the Elwind management, they said, we want to do it the Dutch way. And it's an interesting statement, but what it essentially means is they want to do a lot of the detailed data gathering themselves, take responsibility for the grid connection, and then they will auction a tendered site. And so, that was part of the whole many times mentioned roadmap, and why that is successful, because you take the risk away from the developers. Also, we are working with Utilitas. We've helped them to prepare the grant application for development funds, and we're doing some other work packages at the minute as well. So I think for us as a company, we're really starting to get embedded in the Baltics, and I think that is great to see. We're very happy that we get those opportunities. This is only my last slide, so now I'll do a bit of walking around and chatting. And this is the art of development, and I call it an art. Why? Because it's a permanent set of dilemmas, and I've listed a few here. And if you've done a lot of projects before, you will see it doesn't matter if it's oil or gas or if it's wind. All the dilemmas are almost always the same. Of course, you can read it as success factors, but the flip side is also true. If you get it wrong, that is your lesson learned or your failure. Gert-Jan already talked about data. I compare oil and gas projects with wind projects, and there's two essential differences. The footprint of a wind project is much larger, the spatial area that you need. Rather than one complex facility like a refinery or a plant, this is very much spread out. Therefore, the data is so much more important. And the other one is the repeatability and the logistics. So you build a facility, I don't know, 60, 70, 80 times. And those are the two big differences. And they come with some of those nuances of these dilemmas. I think I can look there as well. So sound basic data we talked about, although it is very costly, it will pay off to actually do your wind measurement, but certainly also your soil investigation efforts early, because you will need it to get a credible relation going for your design and your supply chain engagement later. One of the other dilemmas, and this dilemma is one around cash. So you are still very uncertain into either the regulatory regime or will the project actually get a permit, yes or no, but you still need to spend development cash. So that is the dilemma, and it's an art. Second one is design. Very many projects, and that is regardless which sector you are, think they make progress by doing a lot of technical work. Why? Because it's easy. It's in your own control. You can hire the right engineers and they will get it right. But that's not the point. The point is that you get it built properly. So if you give the design completely to a contractor, he will make it such that he can build it efficiently, but it's not smart designed, or maybe not as smart designed. On the other hand, if you give it to a design consultant, he will optimize the design, but it's not very buildable. And that is also a dilemma where you need to find the middle. Talking about supply chain engagement, I think an anecdote was we are now all worried in the wind industry about, are there enough installation vessels? Can the turbines be produced? There's nothing new here. I was working a lot in gas compressors had a lead time of 3 to 4 years at some point. So what did the big oil companies do? They ordered a whole tranche of compressors and they started to trade compressor fabrication slots. Actually, what we now do in wind development, every now and then, we've advised one of our clients, we're looking at vessel reservation slots. So you work with contractors and you can actually pay them to reserve a slot. And if you don't need the vessel in the end, you can trade that slot. So there is innovative ways to fix that dilemma as well. Also, I think probably the fourth point is the most difficult one. And I think I would want to focus on what I call the 3 T's. And the T is about transparency, it's about trust, and it's about team. Let's start with transparency. I think Gert-Jan already said it. These are multi-year undertakings. You cannot change direction all too often. At some point you need to wait. Once you've chosen your options, you need to zoom in and stay stable. And you need to be transparent. If you look at the development and the execution effort of these projects, literally thousands and thousands of people are involved. And you can't change course all the time because you don't get the whole crowd walking in the same direction as yourself. So being transparent about your plans, being clear to the supply chain when you choose to tender, so this is not tender for getting the site, but tender for the execution contracts. When do you, and be reliable on that. So be exactly clear when you want to choose, how you want to choose, because also the companies like Van Oort is represented here, but all the other supply chain parties as well, they also need to manage their resources in their portfolio. So this stability is extremely important. When I talk about trust, I think about Carlis Goldstein, I think is the right word. Maybe he's in the room, I don't know. He was talking a lot about trust as well. So if you want to get these undertakings right, you need to invest into the region. You need to rely upon the government roughly going to do what they need to do and when they do it. You need to rely on your supply chain partners that they actually also want to do a good project and not just after your wallet as an owner, because that's often the fear. And I think that trust in the end pays off. The project I mentioned, where the Borssele 3 and 4, so number 2 out of the 5 in the roadmap, actually the 2 contractors were the developers. They started the development. That was Van Noord and Vestas. And they got parties around them to help develop and invest and then play the owner's role. But there never was a tender for the EPC. It was just a good benchmark, sharp design, good negotiated contract. And in the end, the contract ended up being successful, but also benchmarked as one of the cheapest projects. And people find that quite difficult to believe. They think that you only get value out of cutthroat tendering, but that is actually not necessarily the recipe for a good result. So that's all about the trust. And the last bit is, I think it's about team. Classical dilemma here, again, is between, if you like, the commercial teams and the technical teams. Commercial teams, they have a few things, regardless of any industry, they have in common. They want optionality, they want flexibility, they want as fast as possible, as cheap as possible, but want to decide as late as possible. That's what they always do. And the technical team wants exactly the opposite. Now, I think, in the end, successful projects are where business meets delivery, or development and delivery. Because the business people are good at what they do, and the delivery people are good at what they do, and they need to invest in that collaboration, that team trust, that will make or break your project. And I think later in the panel we're allowed to share some stories on how you can mess that up as well. And there are a few, trust me, but there is also very good examples. Want to finish off the development with where I should have started. And that is, do you really, as a project, know your drivers? We've heard a lot in the last day, or 1.5 days, about the target in 2030 and the 100% or 120% coverage of demand. So it's all about schedule. And I quote a former leader of myself who said, schedule-driven projects are the projects that get cost-driven a bit later. In the end, it's always about cash. So I've not heard enough about affordability. I've heard a lot about, will it happen in time? But in the end, projects that happen in time, sometimes called rush to disaster. You need to get your front-end development right first, and then you will have a successful project. Because the time you think you save by starting later and spending some development cash later, you will pay later 3-double, 5-double, both in time and money. And with that sort of evergreen lesson for any project sector, I'll leave it for now and give the word to Mark. Thank you.
Good experience speaking there. Thank you very much. Our next speaker indeed represents a supplier of foundation and installation equipment, both for on and offshore wind parks. Max van de Kemenade.
Yeah, thank you very much. So my name is Max, and I'm representing a company called iQuip. And today I want to talk to you a bit about how we reduce the environmental impact of installing foundations. So also, as an arrogant Dutchman, I would also like to have a brief marketing about our company. We have approximately 400 employees globally, with offices and yards spread throughout the world. And our main business is that we have a large rental fleet of equipment, which is used for the installation of on- and offshore foundations. And we've been involved in the offshore wind market since the early 1990s. So that early involvement also makes that we've installed a lot of piles. So we've installed over 6,000 piles in the global offshore wind market, of which the largest part is monopiles. And today we're proud to say that we're involved in some way in most of the offshore wind projects taking place globally. So what is the problem I would like to talk to you about today? The problem is that we see is that installing a wind farm generates noise, both above water and underwater. So when you're generating underwater noise, that impacts marine life, that impacts fish, that impacts marine mammals. And the fact that you're impacting marine life means that governments are putting in place regulations to mitigate the environmental impact. So then the fact that governments are putting in place regulations means, again, that you need to comply with that in your project. That means that it impacts your installation and your operation plans. And we think that keeping that into account in an early phase in your project, knowing what the regulations are, knowing how you're going to comply with that, is key to an optimal installation campaign. So since the early 1990s, we've also seen a tremendous growth of offshore wind turbine sizes. Well, bigger wind turbines mean that you need bigger foundations to put them on. Bigger foundations mean that you need a bigger hammer to put the foundation into the ground. So, does a bigger hammer then also mean that there's more noise? Well, firstly, a bit on what is actually noise. So, looking at noise, there's a key difference between above water noise and underwater noise, which I would like to first briefly explain. Looking at underwater noise, you see at the bottom right there at the indications that we have measured background noise levels in the North Sea for approximately 100 to 110 decibels. So this is underwater noise. If you have 100 decibels above water, that's a very loud festival that you're standing at, so that's completely different. We've also measured, for example, when it starts raining in the North Sea, the noise level increases to approximately 10 to 15 decibels extra compared to the background noise level. When we have an installation vessel on standby in the North Sea, noise level is approximately 130 to 140 decibels. So that's a bit of the baseline that we're comparing against. Now I have an example of what it sounds like. Let's see if the sound works. It does not, so it's very quiet. Now there we go. So you see clearly in the picture, in the movie here, that there's a hammer on top of this foundation pile. You're giving a blow. The blow transfers a shock wave into the foundation pile. That foundation pile starts vibrating, and you see that vibration clearly in the water as well, and that transfers into the water column. So that's what we're dealing with. So what noise is then measured? So this is a bit of a complex graph, but I'll explain it. On the horizontal axis here, you see the diameter. So that's the diameter of the foundation pile which is being installed, starting from 0 meters all the way to the right to 10 meters. And on the vertical axis, you see the sound or the noise which is measured. So each of these pink crosses, they represent a specific project where a specific noise level was measured based on a certain pile dimension. And you see a general trend. So looking at an 8-meter diameter pile, for example, a noise level of approximately 180 decibels is measured, and this is in an unmitigated state. So you just have a hammer on top of a pile without any noise mitigation applied. Noise level is approximately 180 decibels. So that's the base case. So what do we then see? Well, we see noise legislation is being put into place. There's a noise legislation in the Netherlands. But what we also see is that each country implements their own noise legislation, which becomes quite complex. But I won't go into all the details of these different noise legislations, but I would like to zoom in on the German regulation, which today is still seen as the most strict noise regulation to comply with. So the German regulation is set into place to protect mainly the harbor porpoise. So you see the picture here, that's a type of dolphin which is present in German waters. And the German regulation states that you need to be at 160 decibels or lower at a distance of 750 meters from the foundation pile. So 750 meters is a distance which we see coming back quite often. And I actually don't know why it is set at 750 meters or not at 500 meters. But this is a value that we keep seeing coming back. So it's safe to say if you can comply with German legislation, then you can comply with most of the other countries' legislations that are in place today. I did a bit of research when I was making my presentation if there's any noise legislation in Estonia. I am no expert on the legislation in Estonia, and I heard yesterday as well that there are plans for bringing it into place. But I guess it's safe to say that it will be based on the fish species and the marine mammals that are present in the Baltic Sea. And as I'm also not an expert on fish species and marine mammals in the Baltic Sea, I did find a report. I live in Sweden, and this is a report in Swedish where they studied what kind of fish species were present in the Baltic Sea. And there were also some nice graphs which show that they were actually also present along Estonian waters. So the 10 most common fish species in the Baltic Sea are these, and I used Google Translate then to translate them into Estonian, so don't blame me if the translation is wrong. Hearing the laughter, it might be wrong. And also the marine mammals. So I've understood it's a lot of seals which are present in the Baltic Sea, also along the Estonian waters. So my best guess is that the noise legislation will be based on these species and what the impact of sound is on these species. So we've seen noise which is measured based on an 8-meter diameter monopile is approximately 180 decibels. Noise legislation in Germany is based on 160 decibels. So how can we then still build the wind farms without and minimize the impact of marine life? Noise-canceling headphones, that's an option, of course, but perhaps not the most practical one. But within ICE, we're working on a few different technologies, and the quick and easy and cheapest first solution is to adjust the piling method. And so if you use an impact hammer, rather than having full blows at full energy all the time, you can think of a smart way to drive your piles. We call that high frequency, low energy. So you give more blows per minute at a lower energy to make sure that the pile keeps going down, but you don't put too much energy into the pile. Because if you put too much energy into the pile, that will translate into excess noise. So this is an easy way to reduce 3 to 6 decibels. That's been measured. Another solution, this is what we call a source noise mitigation. So this is something that we can add onto the hammer and reduces the noise before it's generated, is pulse. So I will briefly explain this. So pulse is an add-on to a standard hydro hammer. And when you look, if you look at the left picture here, you see the top white part, that is the impact hammer. The bottom red-gray part, that is the sleeve. So the sleeve is what fits over the monopile and make sure that the hammer is guided along the monopile. And in between you have this yellow, blue, orange pulse system, and it's basically a damper that you can add in between those two components. And by adding a damper in between there, we can add a liquid volume. So you see there's a minimum and a maximum liquid volume that we can add between the two. And that liquid volume actually acts as a shock absorber, basically. So you're changing the blow going into the monopile. This has been used now on a few different projects, and the basic principle is this. So you see here a graph on the horizontal axis, you see time. On the vertical axis, you see the impact force, and the different colored lines, they represent a single blow with a hammer. So starting, for example, with the orange-blue line, so that is a standard hammer with pulse in between, but 0 liquid volume. So pulse minimum is what we call that. You have a relatively high peak impact force, so a steep peak impact force, and it goes back down to 0 impact in a relatively short duration, approximately 16 milliseconds. And then the other end of the extreme is the green line, so that's pulse maximum, so it's the maximum liquid volume, maximum damper that you have. And there you see a relatively low peak impact force, but it stays, the blow stays in the pile for a relatively long duration. So you're extending the impact duration, and this technology reduces approximately 4 to 6 decibels. So this can be added on top of the previous 3 to 6 decibels that I mentioned. So this is source noise mitigation. Another technology that we've worked on is what we call the NMS, the noise mitigation system. I won't go into full details here, but it's basically a double-wall screen, which is fully covering the foundation pile. It's placed onto the seabed. It sticks out above the waterline. And in between these two walls of the NMS, we pump air. So you have noise which travels within the NMS into a water which is inside of the NMS, hits the inner steel wall, goes to air, hits the outer steel wall, and then would go into the water column. But because of the system setup, we are able to reduce quite a significant 17 decibels. And we actually have just completed a new version of the system. So this is a picture from last month in Vlissingen in the Netherlands, which will be installing 10-meter diameter monopiles in the German sector this year. But of course, we are not the only ones providing noise mitigation systems. So this is a publicly available report from ITAP, where they measured the different kind of noise mitigations which are achieved based on different technologies. So if you would like more information on this, let me know. But in principle, you see the different kinds of technologies with big bubble curtains, for example, also applied, and what kind of noise is reduced by applying that technology. And aside from that, we're also working on a separate track, which we call EQ piling. So it's a nice picture of Van Oort's Swane, carrying the previous version of EQ piling, which at the time was called blue piling. This is a big blue tank that you see sitting on top of the pile, and this is a new way of driving a pile. So rather than having an impact hammer, which has a very high peak impact force, this is basically a big weight, which is dropped onto the pile. And we think this can reduce a lot of noise. We're planning to test it near shore at the Maasvlakte later this year. Thank you.
Thank you very much. You can guarantee that the audience is entertained whenever you use Google Translate to translate fish names. So thank you for that little extra trick. Good to hear about all the innovation taking place in installing offshore wind farms, and Küürimislusikas also appreciates this silent installation. Did anyone do the reverse translation? What kind of a fish Küürimislusikas is? I didn't manage to, but we will dive into that later. But back to serious business. I'm glad to hand over the floor to Björn Hanneman, who's the business development lead at Outsmart.
Yeah, thank you very much. Can you hear me? Yeah, I think so. Yeah, although I'm representing a Dutch company, I'm a German, and as a stupid German, I did what I've been told. I don't have any marketing slides. So, but let me just let me just introduce something about Outsmart. We are a technical operations manager. We have a 24/7 control center, which is located in Germany, but our head office is in Arnhem in the Netherlands. And yeah, we are involved in a stage where the money is being made. And to my personal history, I'm a nautical engineer, so I was sailing on product tankers worldwide before I joined the offshore wind business in 2013. During my career, I accompanied 4 offshore wind farms in phases from construction into operations. So, and that is now more than 10 years ago. I'm specialized in setting up a control center work process and data integration. And I'm also still, of course, trying to optimize operations strategy while also thinking about AI. Some of you may have heard about this topic, but our main focus is to be efficient as possible. And why we should be efficient as possible? Because during the operations phase, the money will be made. So you need to be as efficient as possible to increase the profit for your project. I've been asked to talk about our experience in the offshore wind business, and was thinking about what I can tell you about this. If it's process related or planning related, I have really nice stories, like one I have to tell. It was during commissioning, and a contractor wanted to hand over a turbine flying out with the team. And they arrived at the turbine after a few hours, and once they were standing at the door at the turbine, they recognized they forgot the key. So what they did, they had to bring the key from shore with the helicopter and spend a lot of money, which could have been prevented if we would have a good planning. But that is not the main point I want to talk about nowadays, because as an operator, we like to be involved in a project on a really early stage. And because I will explain in the next slides, but let me just get one step back. Before you can, of course, involve in an operations department, you have to think about who will it be. And who it would be, it's about to think what kind of operation model, what kind of strategy you have. So you have to be keen on what will be your long-term strategy, how to run this project. Will you be like, for instance, a big utility like Ørsted or RWE? They usually go the hands-on way, which means that most of the processes are run by the owner itself. So they do the operations. They do also, or they want to do the maintenance of the turbines, the balance of plant. They want to do subsea inspections. They want to do everything. But if you are not a big utility which has a certain amount of wind farms, it just wouldn't be profitable enough for you. So you need to be efficient. You need to be clear about what you really want. For instance, the most common way for project organizations is the hybrid mode, which means that certain elements of the processes which will be run through the operations will be outsourced to companies like like Outsmart for operations. But you also have, of course, after the warranty phase, either the OEM, which takes care of the maintenance of the turbine for a longer period, or you invite an ISP, so an independent service provider who takes care of the maintenance. For instance, as a project finance organization, so investment funds or other companies like that, you go rather the way that you give all off to third parties. That is called the hands-off approach. And yeah, but you need to be really clear on what you want to increase the profit of the project. Here are some examples about what kind of implications during phases you have for operations. So like during the development, you're setting your long-term strategies. You need to be keen on that, for instance, the service and maintenance agreement with the WTG service supplier. The detail makes the difference. Why? Because you need to have, for instance, access to the turbine data. So you need to have access to the OPC data, IAC data. You need to have the proper planning within your SMA. Like the project will not be built, construction, then commissioning, then operations. It goes in parallel through the whole period. So you need to be keen on that the SMA will also reflect this operations. And of course, you need to think of environmental aspects. Do you need to have a high wind right through? Do you need to have an ambient temperature calculation in your SMA or not? And if so, then you need to make up your mind if it reflects your actual situation. IT systems and infrastructure. As a power producing plant, you are part of the critical infrastructure, which means that you need to protect your asset against any hacker attacks or whatever. So you also need to be clear on this to think about how it will look like for your project in the future. Construction and commissioning. Operators usually have been in the past involved 6 months or 1 year, depending on the project size, to start with the preparations. But this is far too late. We need to be involved in a very early stage, because during construction and commissioning we are heavily involved in the day-to-day business. The reporting starts with the first production of the turbine, and the first production of the turbine can happen if 3-4 out of the complete project is not built yet. So that means we have a high workload during construction commissioning, which will then decrease once we come into operations. But you need to be clear on this to make your calculations during the development phase of your project, that there will be a lot of costs coming to you for operations already during construction and commissioning. Here are 2 examples of why I'm telling you all this, because one of our projects, we had exactly the problem that the SMA was not reflecting the planning of the construction of the project, meaning that as an operator, we want to be very clear on having transparency from the WTG maintenance contractor. So meaning that we have a redundancy in terms of calculating the availability and allocating the downtimes of the turbines. And we figured out during our usual reporting that the contractor has used a wrong correction factor, which means that too much turbines have been put into the calculation of the availability, while not so much turbines were producing actually. So you have a mismatch. And during one financial year, we got, while changing the correction factor to the actual situation, we had an increase of 1.88% of the availability on the benefit for the owner. So that is one reason why you need to involve an operator at an early stage to bring back the knowledge they have to the development phase, so that you don't end up in a situation which we have here. And the next topic, IT landscape. As I already explained earlier, you need to have the connection to the OPC IEC data of either the turbines or the substations, because you also need, well, you want to know how your asset is performing, so you want to monitor your asset. In this particular case, we run into a situation where all this data were not available for us, so they had to rebuild the complete connection of the server. And while all doing this, it took a long time, it took a long workload for the project management, it took a long high workload for the IT, which resulted in a 50% higher workload for the total team, which was calculated before, just not having the access to the data. So, and then for these 2 particular cases, I really like to mention that please involve the operations department in an early stage. And this is my last slide. And I'd like to thank you for your attention. And if you have further questions on the experience we made as an operator, you're very welcome to reach out to me. Thank you.
Thank you very much. I believe this wraps the presentations. And Edwin, the floor is yours to host the panel.
Thank you. May I invite the presenters then to take a seat, or to staying, whatever they like. in whatever sequence you like to sit.
Okay.
I have about 20 questions. So this panel will last until after lunch. And then we have at least 40 questions coming from you. So we'll handle the whole day. But maybe that's not the best way forward. And I also saw that Terry is standing here with a microphone. So I have one specific question to all four of you. And then if you have some questions, that would be very nice, because then it's about what you want to learn from this panel. And if you don't have any questions, we'll just start my lunch session. Main question I have, hearing all your beautiful lessons learned, what has been your biggest success or your largest failure, which you'd like to share with this audience, and what is the lesson learned from it? And to be honest, I like to hear more about the failures than the successes. Gert-Jan.
Okay. So referring to the failures and the successes, that I think it's about really about aligning plans with reality. And talking about the Netherlands and the North Sea, I showed you this map with the pie of the North Sea. The reality is that the country itself is really densely populated. So there's a lot of people living there, there's a lot of functions. So when talking about the sea, you actually also need to talk about the land. That sounds a bit cryptical, but it's really important to think how to get this energy onshore. There is, of course, now new thoughts about hydrogen connection, but I think the same will still apply there. That get your energy onshore, and either take the shortest way is not always the best solution. I showed you this map with these very long connections of IJmuiden, which is going for auction this year, and will be built in a couple of years. And there's a very long cable there that doesn't take the shortest way to the shore. And the reason is, and you may call it a failure or a lesson learned, I think it's a lesson learned, that the grid is just full onshore. So there was no connection point close to Amsterdam, IJmuiden, any of the ports there. That the IJmuiden means far, so it's quite far into the sea. Actually had to connect to a point much further south, and that crossing a lot of important naval routes, crossing a lot of cable connections, and name it, mine deposits, all kind of other functions. So the lessons learned is don't underestimate the complexity of getting the energy onshore. And it's not just a line from A to B, but you come across a lot of parts there. And for Estonia, we've also seen the difficulties with connecting, finding the right grid connection. It's been discussed yesterday, that perhaps it's good to study different routes, find the best, and the shortest route may be cost effective, but may also result in other complexities. So think about that well, and then be decisive. Sometimes that's just the outcome. That's the way you have to do it. And in the case of IJmuiden, that's also how it's going to be built now, how the plans have been adopted. A connection line to the port of Rotterdam and to Flushing, that's with DC cables, that's how it's going to be. So from a failure to a lesson learned, a reality is getting the energy onshore, which is really important.
So focus on onshore before you go offshore.
You need to understand it's not just offshore. Yeah, you need to understand the connection between the land and the sea. Yeah.
Okay. Very good. Jörn, your one. Yeah, you were thinking that I would go along the line, wasn't it?
Ik krijg jou nog wel.
Yeah, that's good. Jörn.
Yeah. Biggest failure. I think the biggest failure we experienced in our whole operations we did since more than 10 years now was trust in people, trust in the contractors, that they follow the process. We had many cases where it is key for not only for safety, but also due to steer good operation, that you follow processes which are also made for construction, for commissioning, for operations, in all different phases. You have in every phase you have some management where other how to say other implications have the most focus on. Like for instance, the construction manager wants to have the most flexibility as he can get to get the work done. The commissioning manager wants to have halfway. He wants to have flexibility, but when it comes to the energization of the turbines, they want to have electrical safety. And the operations manager wants to have no flexibility at all. He wants to have a safe operation because you are actually producing, so you have an electrical safe status you need to reach somehow. So, but during this period, we faced some issues and lacking of communication and managing the phases or the handover of the phases, which run into situations where, people told what they like to do offshore on that certain day and who is going offshore, but actually you found out that it didn't happen like this and the wrong people were offshore. So, and I think that is really the biggest failure we made in the past, trusting people and trust that the companies are following the processes.
And it's maybe also alignment of people, which you said also, Roland, that everyone had his own agenda, and maybe it's even a good agenda, but they're not aligned. So communication is key in that, I think. Communication is key, and especially when you want to hand over the phases. Like we experienced, we have been involved in a construction, commissioning, and the operations of the Gemini project, which was the biggest offshore wind farm one day also in the world. So we were taking over, for instance, the responsibility of an asset which has been handed over by Van Oord in that case, because the turbine supplier was not ready yet, and so we took care about that asset. Then we had to hand it over to the turbine supplier. It became their responsibility to erect the turbine on a TP. And once they were finished with commissioning, and they handed it back to us. But this this handover, this needs to be managed quite clearly and really planned. In this case, that was a brilliant project. It has been built 6 months ahead of the time schedule within budget. In this project, we didn't face any problems, but this was just an example what you really need to know what needs to be managed, because the asset will be one day you will be responsible, the other day you will be responsible, and the next day I will be responsible. Yeah. So when we need to talk.
Maybe before we come to your biggest success or failure, I think you can react to that one or not. And you must have similar experiences.
Yeah, maybe this is a technicality, but it's quite interesting. If you have a traditional offshore wind farm, you have 2 EPC contracts. One is the turbine and one is the rest, also called balance of plant. And now the technical solution of where do you put your switchgear? Do you put it in the foundation or do you put it in the bottom end of the tower? Sounds like a small technical detail, makes a huge difference when it comes to handovers that you're talking about. If you stick it into the foundation, then you have a little bit of turbine scope in the BOP contractor scope. But what you then do is you put the installation, you put the cable, you commission the cable, you test the cable, and there's nobody else there from the turbine guys yet. Then the turbine comes up and you switch it on. However, traditionally, if you put the switchgear into the bottom of the tower, then first the tower comes, then the BOP contractor comes back to stick the cable in, and he wants to have that space with the work permit to test the cable, and then who's responsible, 3-party safety interface handovers, is a mess. We've done both. So the 2 projects, I was the project director, we had both variants, and I've seen the difference. minimize the handovers and the interfaces is paying for hell. It's really, really good.
Even though offshore wind seems to be simple compared to oil and gas structures, I think, every now and then.
Correct. I mean, it's very different. I said in my intro that the two big differences are the large footprint and the T&I optimization, the logistics. So the harbors, the vessel movements, that's where you make or break your project. But talking about successes and failures, I would like to keep our moderator on his toes. So my two examples both involve Van Oord.
Shall I leave the room, or do you think...
No, so I think, and it's good to say that the success sat in the Borstere 3 and 4 project. I used the word of the 3 T's. It was really integrated team, integrated commercial technical schedule. It was transparent, there was a good level of trust, and therefore it worked well, like the Gemini project. We also had a classical error where a developer wants to be, commercially smart, so they get bidders and they select the cheapest bidder. So this was nothing to do with offshore wind, but I think it's a telling example. We had a pipeline in Gabon, and Van Oord was doing the dredging and the pipeline installation and the shore crossing, but then it needed to be connected to an oil terminal, and there's a bit of process kit. And Van Oord hadn't got a clue about process kit in oil and gas. So they bid something for a way too low amount of money. Of course, they couldn't do it. It didn't work. They needed much more, so they started to fight and claim because they wanted to get their cash back. And the owner gets pissed off because the contractor isn't performing, although he could have known that we shouldn't have selected Van Oord to do that bit of the work. So I think, and it ended up with litigation lawyers and claims and everywhere. Yeah? And in the end, the lesson is you need to be, one, willing to select the party who has an experience and a proper track record, and you need to select the party that has allowed enough cash to do the job. Because we knew, as an owner, that the bid was too good to be true, and of course then it wasn't true. Yeah,
correct.
Yeah, so I think for me it tells the example, one, be clear about who does what and who's got at the job, and allow the contractor to make not too much, but a little bit of profit, such that he can actually do the job properly rather than end up in court.
Yeah, and I think the lesson learned from Van Oord should be, don't propose what you're not capable to do.
Sorry? Yeah, exactly.
Yeah, I mean, that's what certainly happened in the beginning.
Yeah, Van Oord made the error, but also the developer, the owner made the error. So I think you need to be realistic there.
Yeah. Next.
Yeah, I think my answer is a bit boring because I actually cannot come up with a failure that I want to name, but I can share a success.
Shall we put some failures for?
Yeah, please go ahead. I think as a success, what I think we've quite successfully managed to do is to keep up with the growth in offshore wind. It's been a crazy ride, and now I haven't been involved myself personally since the early days, but some of my colleagues have, and they tell me how fast things have grown. Yep. And how every time it was said that this is going to be the limit, so the S2000 hammer, 2000 kilojoule hammer is the largest hammer, we won't go any bigger than this. Well, now a few years later, we're with our hammer at triple that size. So I think that's a success that ICUP has been a part of, but I think the entire offshore wind industry as a general has been a part of. Van Oord, for example, on being able to install those kind of foundations and install those kind of turbines. And I think that's only possible because of the generic sense of cooperation and everybody talking with each other, where is it headed? And I think it's perhaps driven initially by the turbine sizes, bigger turbines coming to the market, but then the rest of the supply chain discussing with each other, are we able to fabricate the monopiles? Are we able to fabricate cranes to lift these monopiles? Are we able to fabricate hammers? So that's something which I think is a success of the wider offshore wind industry in general.
And I think it's underestimated in a way that
it's also a huge risk.
We started with 240 tons monopiles 20 years ago, 19 years ago, and now we're discussing with clients if a 3,000 tons crane is sufficient for the foundations in 5 to 10 years. And it seems to be logical, and things went smooth, but it's a crazy kind of rat race getting up to a level. And it's also, I think, for Estonia, it's a new thing when you see new areas. We were able to step from small turbines and smaller foundations into larger foundations. And Estonia has to start with 2,000 ton. That's also kind of strange way of thinking. There you. Where's there and where's the microphone? Are there any questions? Come on. If there are not any questions, I'm going to ask volunteers to come up with a question. So I think Andrus will have a question. Yes, you're laughing, but you must have one. Holger? Ah.
Sorry. When you are talking about how big everything has gotten over the years, is the sky the limit for offshore wind, or where do you see maybe you get to the maximum of what is possible? Can you say anything about that? Glass ball into the future?
Let's do a quick round. Björn, first reaction in megawatts.
I think we will reach some limit.
Where? Which one? A number. Come on.
Don't push me on a number.
Yeah, I push you on a number.
Maybe 24 megawatt.
Okay. Max?
20.
I think we've passed the limit already. I think we're doing something wrong.
Okay.
I'm serious.
Yeah. John?
Yeah, I can agree. I presented the standard in order to avoid the rat race, which eventually is going to be at the cost of the producers and of all of us. So,
I made a prediction in 2005 that it would go over. 3 years later, we were that prediction. I stopped predicting. But Roland, we are too far already.
Why do I say that? So you were talking about the biggest offshore wind farm in the world. 2 years later, we had the biggest one. It's now tiny, and it used a 9.4 megawatt Vestas machine. And I'm a solid believer that if you are doing something new, you should not do something new on all dimensions. So in the Baltics, offshore wind is new, and there's plenty of difficulties and things to learn. So I think you should go for the proven technology in Estonia. Why? Because on the other axis, actually implementing large offshore wind farms, there's already much new. So if you go on the innovation and technical scale like there, and on the fact that you do these type of projects, then you are in, call it the double uncertainty area, if you know what I mean. So, but I also think that because we are pushing the limits of turbine so fast, there was an innovator guy when we did the project studying 20 megawatt, and we all laughed our ass off. You know, it's impossible. And now it seems to be, well, you're conservative with 20. Huh? I believe you need, in a country where this business is new, you need to select proven scale. So, yeah, well, what is currently proven, there's a lot of 14 megawatts already on the sea nowadays. So that is about right, but don't go and try and scratch to the extreme when everything else is also new.
I think it's not even Estonia. I mean, what you say, I think in the Netherlands, we are looking at standardization and maybe say, Jens, just keep the tip height at a certain level and don't go any further and start to optimize first instead of being more getting larger ones.
Exactly, and I can add to that there's a reason for that, and it doesn't mean to stop advancement in technology, because on many fields there is advancement possible, but for an overseeable time that the projects are going to be built, and then, like you said, proven technology to take a next step, perhaps in 10 years. And I think for Estonia, it's really relevant because the conditions are also different. So the salinity of the water, the soil, the seabed, other conditions. So there's many reasons, and also from a business and project management perspective, to de-risk and avoid getting in too much trouble, because then it becomes uncontrollable and risks grow exponentially. So that's also there will be in future new methods. We know that there's an advances in floating, for example. There's advances in cable. There's advances in conversion. So that will come at some point, and perhaps after 10 years. They are all in the piloting phase. We're also involved. We can learn from that, but they're not ready to be built. So that for that time, keep it the way. And that's why these standards, I believe, will work and help you also de-risking projects.
Roland, you wanted to say at least 3 times.
Yeah, and then I swallowed again.
Yeah.
No, but I talked a little bit about allow the supply chain to make some money. And if you think about the Siemens and the Vestas of this world, they need to innovate so fast so that the 9.5 or 9.4, 9.5 turbine that we used was only sold a few times, and now Vestas is launching 15 megawatt as the standard. But the bottom line is the innovation and the development work that's going into, say, a certain make and model needs earning back time. And both Siemens and Vestas and GE, I haven't heard so loudly, but probably they will say the same thing. They need time to stabilize and to actually cash in on the innovation work they've done. And what you now see is all those companies are actually troubling in their balance sheet, and bottom line is it will come back to the developer, because they need to ask more money to stay alive as a company.
And then it comes back to the consumer.
Yeah. And it's not only the turbines, I think it's also the installation vessels, is same story.
Same story.
Yeah.
And the O&M? Does it make a huge difference if you do 6 megawatts, 15 or 24?
For it doesn't matter how big they are. No, it doesn't matter. Because actually, doesn't matter how big they are. What they do is always the same. They produce energy. So, and if they're coming out of 24 megawatt hour, or if you have 60 megawatt hour, it doesn't matter. It only is for interest of the citizens who will make use of it. So, and also for projects in the development phase, for instance, because you have less infrastructure. Because usually you have an offshore, you have a capped output which you are allowed to build. Like for instance, in Germany, when we started, we had 200 megawatt, we had 400 megawatt. So depending on the size of the project, and because the TSO can just not carry more with their substations, so you are limited somehow, and therefore the infrastructure cost will go down with the bigger turbine. So it is of interest of the owner of the wind farm or the developer of the wind farm, doesn't matter, that you will have big turbines, you will have more production with less development and construction costs.
It's nice to see that you are relaxed on these megawatts, where the rest of us are kind of what's going to happen. It's nice.
Yeah, I don't have to build them. I just have to look at them.
I think we passed the time already, but still, if there's one short question. No? Then I think, there's one.
Well, I'm not sure whether it's a short question, but I'm just curious to hear some of the kind of Estonian reflections on what has been said. So, like, are these experiences useful to you? Are you already integrating some of the Dutch lessons learned? So maybe, somebody from the public would want to come in.
I think the public is in.
It was so
need for
vaguely. I
lunch,
think
but
I go to Tilitas now.
Andrus, thank you for volunteering.
You're welcome. You're welcome. Yeah, definitely. We are implementing the Dutch lessons actually. So we are cooperating with some of the Dutch companies already, and then we have been actually last year. I have been in Netherlands, I think 4 times, and then as Edwin has been around here in Estonia for many years already, then yeah, you have given also a very good input.
Okay, thank you. I think that means that we're now ready with this session. I was thinking about lunch, but I'm 1 hour too early, is it?
You're 1 hour too early.
Yeah.
Coffee done?
Thank you very much. It was inspirational. Thank you. Dear friends, grid permitting and auctions were all passionate topics yesterday during our first panel, and the good news is that we have more key figures in the venue to describe how the state is planning to steer the race to renewables. And we will start this session with three presentations followed by a panel discussion, but there is also a legitimate reason to leave the room should you be interested in our parallel session, because we have meetings with vocational schools and developers. This kind of a session is ready for you in the hallway when you take the stairs up to the second floor. But those of you who are, of course, more interested in what the state is planning, there's a very legitimate reason to stay here. Now, the first gentleman who I'm about to introduce certainly is very worthy of your attention if you have any plans in the Estonian energy industry. His name is Rein Vaks, and he's the head of energy department of the Ministry of Climate. Rein, the floor is yours.
Hi from my side. It's really bright. I really cannot see all of you. Hi from my side. My name is Rein Vaks. I'm working with the Ministry of Climate. From June this year. Been around in the Ministry of Economic Affairs for around 12 years before that, and always been active in the field of energy. Now, a few words about wind energy in Estonia, the place of wind energy, and what we would like to have from wind energy, and what the government is willing to give against the possibility of having wind both onshore and offshore here in Estonia. To start up with, this is really really important. Each and every country, each and every member state should have their goals. You cannot work without your goals. So before the Russian aggression against Ukraine, we also had our goals, indeed. This is true. Those goals are presented in red on this slide. After the aggression, we decided to speed things up. So we raised our goal for renewables to the maximum that we could possibly get. So instead of 63% of renewables by 2030, we decided we need to have at least 65. And this consists of three main sectors. The majority will come from electricity. Until the aggression, the goal was to cover around 40% of production from renewables in electricity. The goal for 2030, the newest one, is 100%. This is ambitious. One of the most ambitious goals in the Union as a whole. In heating as well, nearly 70%, and of course, transport remains 14%. Transport isn't the most favorable topic among Estonians, unfortunately. None is the renewable part in transport. Among that, we need to keep in mind to be as effective as possible and consume not so much electricity or energy as we would like to. So we need to be, we need to keep in mind energy efficiency as well. And of course, synchronization to the Central European network should be fastened up. We managed to fasten it around 11-12 months, so it should be done by the beginning of 2025. I'm here to concentrate on this part. we need to have 100% of renewables by 2030 compared to the consumption. The consumption we foresee is around 10 terawatt-hours per year. This doesn't mean that we will not produce any fossil electricity or import any electricity at all. This means, figuratively speaking, that we have 10 terawatt-hours of renewables in the grid, plus around 4 terawatt-hours of imported or domestically produced from fossil fuels electricity. So it doesn't mean that we consume only renewable electricity. During the summer 2023, we gathered all the developers of wind parks and made a little analysis. The analysis showed that the goal of 2030 might be achieved 100% by onshore wind. Even more, the potential for onshore wind is around 6.7 gigawatts. The potential for offshore before 2030 40 is around 3.6 gigawatts. So this is enormous compared to the consumption rate we have these days in Estonia. The Estonian energy policy follows the line that whenever we can have anything against the market, we should. This is the optimum for the consumer and for the economy as a whole. Nevertheless, we are a strong believer on the issue of offshore developments. We have a lot of potential for offshore. It exceeds roughly by 2 or 3 times the consumption that we could have here in Estonia by 2030. We have at least 3 areas where the projects are quite highly developed. The potential for those areas is around 3.6 gigawatts. And the initial timeline for such project is around 2030, 2032, something like that. So it depends on really different issues. In addition to those projects, the state is also pre-developing an area, the wind area. We are pre-developing it with our good southern neighbors. The northern neighbors are also good. The Latvians, and our goal is to complete the pre-developed area by the end of 2030, a bit before that. When it's pre-developed, we should put it on an auction. The best bidder will achieve the right to develop a wind park on those sites. The developments. In addition to the developments, you need to have something to tie the development to. So we need to talk about grids as well. The grid, the electricity grid, the TSO's grid is constantly evolving. And these days we see that the 4th connection towards Latvia, it's ongoing. We would like to see it ready by the end of 32, beginning of 33, somewhere over there. The faster the better from our point of view. It's crucial for the wind parks near Saaremaa, near the large islands in Estonia. As shown before, there are several potential parks that could produce electricity already somewhere near 2030. Getting the grid near as possible and as soon as possible is utmost important for us. In addition to that, the third connection to Finland is also important. We see that it could be ready by the beginning of 2035. It's pending again on several issues. And another, perhaps most ambitious goal, which is still under scrutiny, is to have a direct connector towards Germany, the Baltic Wind Connector, around 2 gigawatts. And when things go as planned, and they usually don't, it should be ready around before 2040. So it's still something that we are considering with our German colleagues. Yep, well, this is something that is strongly under a bold asterisk, a possibility for a two-way CFT. This is something that the government is still analyzing, but as a whole, we would like to conduct a CFT towards the 2030 targets. There are a lot of elements that are still open, but in a nutshell, the two-way CFT would be for around 6 terawatt-hours of renewable electricity. In principle, and this is important, we would not like to support any electricity that was not consumed in Estonia. This is really important. We cannot, and we are not rich enough, although we would like to, in principle, support the Latvian economy or the Finnish economy through our subsidies. So this doesn't function from our point of view. We are still a bit hesitating about the possible quantity, 6 terawatt-hours. Still, things are under discussion. The latest news from yesterday is that we are talking most probably about 4 terawatt-hours plus something, possibly. And yeah, one additional issue, we would like to have the onshore parks in the bidding before, and producing before 29, and the offshore parks not after 2032. So this is also important. We see that there is a gap between the developments of onshore and offshore, and therefore we need to have a bit more time for offshore parks. Now, last but not least, we have been striving towards a more smooth planning of those developments. A lot has been done, a lot of details are still on the plate. First of all, and this is something that is already done and functioning, we managed to free up some grid capacity. We used to have a lot of capacity booked, but not used. So a few changes to the Electricity Market Act, and kaboom, 4.4 gigawatts of capacity was freed from the grid. The repower package, we would like to have all the processes as fast as possible. So the proceedings with the environmental board should be not longer than 12 days. This is where we have put our money. We have agreed to have some further funds for the local municipalities to fasten up the plannings, the proceedings. And another issue that I would like to discuss is the fast track for developing the grid. As mentioned, you don't have a lot of need for a development, a renewable electricity development without the grid. And these days we see that the grid development will take some time. This is not okay for us, so we are constantly looking for some possibilities to speed things up from that side. And we have found a way to speed things up around 2 or 3 years. So this is currently under discussion in the government. We hope to find a way to the parliament around summer this year. Hopefully things will be changed by the beginning of next year. So this is the main topic from my side. Yeah, any questions? Thanks.
Thank you, Rein. I think we will leave the questions for the panel. You're not leaving, are you?
Nope.
No.
Absolutely not.
Rein is staying, so put your questions either in writing or just ready in your head for the panel. But I'm happy to invite now onto the stage Kristi Talving, who's the Director General of Consumer Protection and Technical Regulatory Authority of Estonia. Go ahead.
Yes, thank you, and good morning also from my side. Being now more on detailed level than Rein. Rein gave a really good overview of the policy side, but the Consumer Protection and Technical Regulatory Authority is the authority who carries on the auctions of offshore wind, and also the permitting process is in our authority. Just a short overview, as said yesterday, it all starts from the planning, and maritime plan was approved in 2022, and that allows us to carry on the auctions of offshore. At the moment, we are concentrating more on the areas around Saaremaa, as the court overruled the special planning around Hiiumaa. It takes a little bit more time before we can give out the areas around Hiiumaa. But these yellow or light green places in the sea are all these areas that at the moment the developers are interested in. So going to more detailed, as it was shown today and also yesterday, there are today 3 parks that is already ending its environmental impact assessment phase, and already discussing with our authority about the building processes and building permits processes. So we are really happy that at least 1 or hopefully even more parks will be ready by the 2030. There's really big potential now. But what I wanted to talk about more is the second wave projects that we are auctioning out at the moment. We had the first Estonian first offshore auctions in December and January. There are 2 areas, Liivi 1 and Liivi 2, and both of the areas, around almost 200 square kilometers, were auctioned out, and the winner of the areas were Lithuanian company Ignitis. So we're really glad that there are more foreign investments coming also to Estonian market, and there's not only Estonian companies who believe in offshore potential, but there are also foreign companies. But this is not all. Within following days, we have another auction, the area called Saare 1, and it's west from Saaremaa, around 60 kilometers from the island, and the area size is 88 square kilometers with a starting price of 1.3 million euros, and the auction itself is taking place from 27th of February. All the auctions in Estonia are online. And hopefully during this week we'll get to know how many companies are interested to participate in the auction. And what next? We are not stopping there. We are at the moment planning already 3 more auctions, which are also the areas southwest from Saaremaa Island. And these auctions itself will take place probably in the end of May or June. As we are now hoping and allowing all the companies to come to the, let us know which companies would like to participate in the auction, so we are all welcome. The deadline is 1st of April. Just let us know if you want to participate. And all the 3 areas auctions are taking place in a row, so in the, hopefully within 1 week or 2. And you'll probably ask why are the areas as these sizes as they are. It's a little bit shortcoming of our building code, which determines that the government itself cannot mark the areas to be auctioned, but all the areas are marked by the applicants, by the developers, and we are auctioning out the areas that the developers are interested in. And of course, we are not stopping also there. There are a few more areas, I think at least 5, coming to the market also in the second half of this year. but a little bit more of the process itself. We are actually giving out during the auctions the possibility to apply for superficies license, which is up to 50 years, with the possibility to prolong it for another 50 years. And the auction itself is really easy. The companies need to give us the applications who are to participate in the auction, describing their little bit of with 10 points, who is the company, what they are dealing with, what kind of areas they're interested in, how is the financial scheme, what is the progress after the auction, and what are the technological fields and applications that they want to apply in this area. And the auction itself is basically online, and the best bidder is winning, the highest bidder is winning, and the starting price is 15,000 euro per square kilometer always. As the Estonian way, we have only, government has done only the marine planning process, but all the environmental impact assessment processes needs to be done by the developer itself. The deadlines after the auctions are very short. How to say, it's like the EIA program itself needs to be approved 18 months after the auction. And EIA report needs to be given to the approval 24 months after the approval of the environmental impact assessment program. And altogether, there are 5 years period where the developer needs to, the building permit needs to be issued to the developer. It's 5 years after the auction itself. We know the timeframes, which they are very, very short, and therefore, as Rein already said, there is under the discussion of legal act that also cuts the red tape and accelerates the process a little further. There are 3 main changes in plan, as there's first, and I think the most important one is that instead of 3 permits that developers need to apply now, superficies license, water permit, and building permit, there will be in the future only 1 permit. And it hopefully makes the permitting process itself shorter, up to 2 years. The second biggest change is acceleration of environmental impact assessment proceedings, which basically means that all the researches and everything are cut into smaller pieces, and you can do it not in a row, but in parallel, as a parallel process, which also saves the time for the developers. And the third one is simplification of process of renewal of electric wind turbines itself. But of course, in addition, there's grid development plans that Elering is going to talk right after me, and I'm glad that we are now in the situation where starting from next year, the height restrictions of the wind turbines are also abolishing from the market. But more, we have really much information on our webpage, so please visit our webpage or just take a contact with our email address, and we're glad to meet and give you more information. Thank you.
Thank you, Kristi. We're now going to hear the TSO's view. As already mentioned, Oleg Chernobrovkin is the head of energy systems planning at Elering. Go ahead.
Hello, good morning, everyone. It's very exciting to be in a very huge and important audience, and I was thinking that I'm working in Elering since 2007, and I see it's actually the most interesting and challenging time is now. So I have seen the increase in the investment needs, in the number of challenges, and especially now, today, it's we have different challenges ahead. It's synchronization, the energy security, security of supply, and now the big challenge is also the renewable targets. And today I'm going to focus how Elering can support the renewable energy expectations and goals. So we have working actually quite a bit on this topic, and we have come out with the program named Renewable Energy Program 100. And the focus is on the 2030 goal, as Rein described. So the expected or predicted consumption will be around 10 terawatt-hours. And we need to have in our system sufficient amount of renewable power plants that can annually produce the same amount of energy. And in our opinion, or let's say we have done also some analysis, this whole portfolio that can ensure this target and at the same time can assure that we have the needed amount of security of supply is around 5,500 megawatt of power plants. It is about twice as much installed capacity that we have today. And for transmission system operator, taking into account the lines capability to transfer power and also the operation of the system is a big challenge. But now I'm going to talk about how we are going to tackle with that. So the needed renewable, we see that there are three main technologies that can fill the majority of this need. It's onshore wind, offshore wind, and solar. And by 2030, we have constructed the working assumption for the power plants portfolio in Estonian power system, and this is the before named 5,500 megawatts. We already have some amount of wind, and the solar has really boosted, but let's say roughly half is still missing related to energy. And the most cost-effective way to fill this gap is probably the onshore wind, and also some solar is still be capable to be installed in the system. So these are the sources what are currently on our table regarding the working assumptions, but I already now tell you that this is not fixed, so it's not the ultimate portfolio. We are looking it over in time based on the real developments and inputs from either developments or ministries. So this portfolio will get more precise and precise in time, and we cannot say that, for example, also offshore wind will appear in this list. But this is a starting point and working assumptions. So definitely we need to have some grid reinforcement for that additional amount. And maybe also picture why we believe that this onshore wind is able to cover this gap. This is already old picture from last year, and Rein today said that actually the mainland capability is around 6 gigawatts. So, but even if we take this old information that the potential is around 4 gigawatts, then it exceeds already more than two times this needed onshore capacity which we have to install to the network. And we see that this onshore capacities and also solar will be connected mainly to the 110 kV network, which are like local and distributed among Estonia. So, what Elering needs to do to accommodate this additional generation? At first, we need to ensure that we can finalize the investments that are ongoing and planned in short-term future. So the regular investments and all the big investments we are having ahead, it includes around 2,100 kilometers of line. So it's a really huge amount. And the most important projects, let's say the big projects, are synchronization with continental Europe, which allows us to reinforce some part of the 330 kV network, and the synchronous condensers are also really important part if we look the combination of the renewable energies, which power plants are usually connected to the grid via power electronics like converters, and it means that those technologies need actually some short circuit power and the system to be like stable during this time when there is only renewable. We need to have inertia, and those will provide also inertia, those synchronous condensers. So we are doing a lot during synchronization actually, which enables us to move towards the renewable based system operation. Also the control systems will be upgraded, and this is a base to go on to add those additional functionalities. And also I will mention Estonia, not Estonia, Latvia, but Estonia, Finland, the Estlink 3 project, where we have also included those internal reinforcements. And with this project, we will upgrade the whole 330 kV network. Why it's important? Because 330 kV network, it's the highest voltage in Estonia, and this is forming like a backbone of Estonia power system. And the whole backbone need to be upgraded. The strength of the backbone is as weak as the weakest link. So with this Estonia, Finland, Estlink 3 internal reinforcements, we actually achieve where all the 330 kV lines are upgraded. But still, something is missing. As I said, we foresee that the generation will be connected mainly on 110 kV network. Then we need to put additional resources on that network compared to today's amount of investments. So we have estimated that the additional need is around 1,000 kilometers of 110 kV overhead line reinforcements, and also a few kilometers of cables. And as we are doing that to increase the distributed renewable energy, we need to increase also the coupling between 110 kV network and 330 kV network. So there are a number of expensive transformers need to be installed between the 110 and 330, and also some substation expansions and also new substation. So it's a huge amount of investments, and how we are going to make them on time. Yes, with today's concept, where our grid development responsibility is only limited with the investment that are needed for the current clients and the prediction of the forecast of the consumption increase, then this is not sufficient. For the additional power plants, our current usual process is that the client comes, we do the calculations to see what is the impact of this additional megawatts, what the power plants is going to install in the system, and then find out the grid strengthening needs and apply those costs into the connection agreement. But as we foresee that those majority of amount of this capacity connections will come to our table 27, 28 probably, then taking into account that this grid reinforcement takes about 5 years, we are not able to do it in time. So we need to change the whole paradigm of the connection and the new concept, how we can do it, that we need to have the rights and the capability to make those needed reinforcements before the client comes. So when the client comes, 27, 28, we already are in a process of this, strengthening the grids. And how we are exactly going to do it, how we will find the necessary investments. Today, we have in our house ongoing a new, first of its kind development plan, where we try to take into account this 5,500 megawatt power plant portfolio and having our best estimate assumptions about the locations and capacities. So we are doing the network analysis and we form the first development plan. And then we will have a list of additional investments, and at first the amount of those, let's say, uncertain investments, it's bigger than the certain investments, which we can already go into the procurement and construction phase. And during time, looking at the actual developments, we are renewing this, or we are doing additional network calculations with updated assumptions and input. And at some point, we get sufficient maturity level where we can say that the number of investment needs is already at this stage where we can make investment decision and start to work with those. But still, probably some part of the investments will remain, which we see that, okay, it's it can happen that it can go right way, but there is also a chance that we are wasting the investment. And then we are planning to do additional risk analysis, like comparing how much risk is due to the not doing the investment, how much compensation we need to pay to the power plant when the number of hours is very big. And when the amount exceeds the cost of the new line, then of course it's better to put this line investment into the certain investment package and start to work with that. But if it's the way around, other way, that the number of hours is really small, then it's economically feasible actually to keep this investment in queue and only activate it when it's really needed. So this is the philosophy how we are going to implement these investments. And also, because we are doing the investments in advance, we need to change the current connection process. So we have proposed that the new connection cost could consist of the grid development part and the connection point construction. So all these costs can be 100% be fixed. And the philosophy of the 1 megawatt grid development cost that we divide this overall necessary grid development investments with the megawatts we foresee we need to install additionally into our system. So it's around 88,000 megawatts per 1 megawatt. But as these investments are also beneficial and needed for the existing clients, maybe not in these coming years, but in longer term, after 10, 15 years, then the benefits are on both ways, and the plan is to share this cost. And then 44,000 megawatts per 1 megawatt will be for the power plant connection client. And the other part of the connection cost will be the connection point construction itself, like substation extension or the circuit breakers, etc. And also the part, like when someone wants to connect to Ruhnu Island, then we will not socialize this part of the additional investment to existing clients, but this additional extension of transmission network will be applied also to the connection price. So this is the proposal, what we have worked with ministries, and we are proposing to make things new way. And at last, also the operational challenge. The system operation gets much more difficult, so we need to have additional frequency reserves, and control everyday work gets more complicated, so we need to get more signals, more measurements, more functionalities. So all these very complicated, already complicated SCADA and real-time operation systems need to be upgraded. Yeah, and as I focused only on 2030, then we have some visions also beyond this period, and I will not stop too long here because Rein already also mentioned these longer-term plans. Thank you very much.
Thank you, and now it's time for the panel, and I'm pleased to invite onto the stage the moderator, Sander Elias, attorney at law firm Trinity.
So, hello. Thanks to everyone, and we have now about, I think, 15 minutes to discuss. So about 15 minutes to solve all the challenges ahead. Really ambitious. So let's get started. And in my questions, I will focus on offshore wind, and then we have also questions from the audience. So the first question goes to Rein. The developers of the so-called first wave offshore wind projects have said that they plan to receive all the necessary permits in the next couple of years, and that getting ready by 2030 is still possible. So could you give us a short overview of the steps that the Estonian state plans to take so that offshore wind could be realized by 2030? For example, you mentioned this CFD scheme, but will it be composed in a way that it would be actually suitable for offshore wind? What is your perspective and view?
Yeah, thanks, Sandor. I think that there are two main pillars to this question. First of all, the permitting issues. This takes a lot of time. It takes unnecessarily a lot of time indeed. So from our point of view, the shorter the permitting issues, the better. The better for the developers, evidently. So those are the issues that we're currently struggling. So Kristi already mentioned a few bills that we have in the parliament. So this is the first pillar. The second one, the second one is actually grids. So you cannot have any production before you have any grid near the development. And this is also something that Oleg already mentioned. We are dealing with that. We are trying to have the grid near the development as soon as possible. And indeed, you are right. The third option, the third issue would be to have a boost towards having offshore wind on the market before it would come on the market terms. So that's the reason why the government is currently discussing the possibility of having a CFD scheme. It should be, indeed, as you mentioned, it should be technologically neutral, and it should give all the possible developers the possibility to get into the scheme and therefore cover the whole 2030 goal with the minimum cost to the society.
Okay, so let's take the second pillar, the grid. Oleg, from your slides presentation, I understood that there will be additional grid investments in relation to this new grid development concept, and that you will evaluate the readiness of the renewable energy projects. But does Elering, in its plans, take into account the possibility that at least one offshore wind farm could be connected to the grid by 2030 or not? Is it possible or not?
Yeah, as actually I mentioned in the presentation also, we need to start from some point. And today we see that more probable is a version where this offshore wind will come in later stage. But if we see that the offshore wind can step in earlier, of course it's possible. And then we need to adjust our development plan because it has quite big impact on which grid part you need to reinforce. Either it's like more distributed onshore wind or very high capacity concentrated offshore wind. It will be probably connected to 330 networks. And then the ratio between the 110 kV reinforcement needs and 330 reinforcement needs is the balance is changing. And it's possible, but we need to be very sure then about it. So we are not rich enough to make like the grid available or for all future possibilities. So we need to keep the track and really base our decisions on the best knowledge and understanding what we have.
Okay. And now to the first pillar from Rain's thoughts, the permits. Kristi, have you in your agency already thought or prepared how the issuance of the permits could be as fast and smooth as possible in relation to the current regulation and also this so-called combined permits? Or do you see that the regulation itself is good enough and everything will work out nicely?
Yes, this is something we are struggling every day, finding the best solution and also trying to learn from the countries who already have several offshore parks. What we are believing ourselves is the predictability of the situation and predictability of the future is most important for the developers, that they know what will happen next and that they know that this legal framework is stable. And I'm glad that the government also prioritizes now the permitting process and really trying to make it more and more efficient. As I told the legal acts that are in negotiation process at the moment, we really believe in that the so-called second phase projects already have much better conditions regarding permitting as first wave ones. And the combination of 3 licenses together instead of 3 separate licenses, it definitely gives an advantage of bureaucracy side, as all the developers just need to have the interconnection with government officials once, not regarding 3 permits. And ourselves also, we have hired more people. We put the focus really on the permitting process, and we try to make it as fast, as efficient as possible. But together with all the other agencies, we have meetings at least once a month to discuss the issues and how to make it more and more efficient. And I think also that I also want to say that I'm really thinking that we have a good cooperation with developers itself. They are asking questions in advance, preparing documents in advance, and regarding the first wave projects, we are already talking about how to apply building permits, how to do it, and how to collect the information that governments need instead, just to make the decisions quickly. So the interaction and cooperation with the developers is also a big part here.
Okay. If we take a longer term picture, as I saw from all of your presentations, Estonia has quite a huge offshore wind energy potential. So, Rein, what is Estonia's long-term plan? How to best use this resource for Estonian economy? For example, do we want to export electricity and hydrogen, or do we have a certain plan to attract energy-intensive foreign investments? What is our plan?
Yeah, that's a good point, actually. I think we shouldn't produce electricity just for the sake of production. It shouldn't be the goal. Indeed, we have huge potential for offshore wind. This is true. However, it would make a lot of sense if you could harness this energy and well, store it somehow to the economy, to the benefit of the economy. So these days, together with the Ministry of Economic Affairs, we are trying to, well, how should I put it bluntly? We are trying to scale up a plan or some kind of possibility to have some further investments into the economy, to have some further demand for electricity, for energy, whether it's, I don't know, storing electricity into hydrogen, whether it's some other electro-intensive consumption. It's all up to the economy, and it's all up to the possibilities how to harvest the wind energy as a whole, whether it's onshore or offshore. But one thing is for certain. We need to produce electricity for the sake of our own economy to build some further, we need to become richer by that. So this is the whole goal. I think this should be the goal that we have to harness.
Okay. Oleg, from Elering's point of view, from Creed's point of view, you also show us the map where there was this Estonian-Latvian fourth connection near Saaremaa, and also this possible connection between Hiiumaa and Saaremaa sea areas. But we also have huge offshore wind farm areas near Kihnu and Ruhnu islands. What is the Elering's perspective? How we could cover with grid all those potential offshore wind farm places?
Yeah, definitely the potential is much higher than the expected need on today basis. And the network condition or situation in those different places is different. For example, those Liivi Bay areas, it's already today actually possible with not so many additional lines to make this connection possible, because the western in the western mainland part of Estonia, Latvia third interconnector lines are moving on this western corridor, and the distance to this or the access to the 330 kV network is not so huge. So it's kind of realistic to actually make these radial connections there where it's needed. Of course, when the capacity is exceeding the needs for Estonian system itself, we need to start finding the routes how to transport this electricity then to outports towards north or south. And the situation in Saaremaa is different, that the distance is longer and it takes more time to get access there. But there are like pros and cons as always in life. So this western loop through Saaremaa is probably more future-proof. So we see that anyway those offshore wind areas will develop in future, not only in Estonia, also in Latvia, in Finland, in Sweden. And as you know, the first version of offshore network development plan was issued. And it foresees huge potential and needs actually for the offshore network infrastructure and capacity for whole Europe is needed. And Baltic Sea is one important key, let's say, player among together with the North Sea and the other parties. So taking this long-term future into account, this is definitely we cannot pass this, that this network must come there in some point of time, but the question is when.
Okay, and the last question from me goes to Kristi about those auctions. We are auctioning out the so-called second wave areas. From your point of view, is this auction regulation a success story or not? For example, should we take account actually something else additional to the money, or is it okay as it is?
I think there's always two sides, but we need to start from somewhere. And this was the fastest starting point according to our law at the moment. And the aim, we need to look more further than next 5 years. The aim is longer. I think we should have a bigger aim that we have at the moment. We should be looking as Estonia. We can look Estonia as a Baltic hub for offshore wind in the future, and giving out all the areas for the developers is the first step. And I'm glad that we are now actually moving. We are actually on the process. As long as government holds the special areas of itself, then nothing happens. So we shouldn't be looking so much of the criteria, but as how quickly we can give out the areas to the developers. As looking for 2030 plus, I think we are in the stage where all the areas are out, all the areas are already in building process. There hopefully are new technologies on the market that helps to take maximum of the developers from the areas. We're talking about 7% of Estonian sea that we are giving out now, which is covered with marine spatial planning. And this is something really important, not the way how we auction it, but the outcome, when and how quickly we can build up the parks.
Okay, thank you. So as I understand, it's already lunchtime, but there have been some questions from the audience or this online system.
Morning. I'm not going to introduce myself again anymore. I'm not sure if I have a question, maybe a call, maybe. I sense two messages from Estonia to the outer world. First message, we have 3 gigawatt in development. TTJ is doing concession tenders for another 8 gigawatt, 6 gigawatt, I mean, checking the density, so we'll could have 10 gigawatts in Estonia in the early 30s or in development. And 2030 is tomorrow, eh? We are making contracts for 27, 28, so there is not so much time anymore. So that's one thing. People come here, we have the development, and then there's another message saying, well, we have a goal till 2030. I don't hear anything about a vision or something else after 2030. And I see a government handing out concessions for 10 gigawatt, and on the other hand saying, yeah, we only need 1 gigawatt ourselves. There is a huge opportunity for Estonia to more or less, as the only country in Europe, to produce and sell as much energy as they use themselves. And I don't hear a vision. I don't see a clear statement. I don't see one voice coming from the government. It's puzzling me. It's puzzling me how you can have a government saying more or less 3 different messages and not one direction, and not having a vision for the day after tomorrow. And you may react to it, but I don't want a reaction now if it's not a reaction, but I urge Estonia to do something, because how do you like to have people paying some millions for a concession, investing multiple millions in environmental impact assessments, asking them to do a building permit within 5 years, knowing that you won't have a vision and you won't have a grid connection in 5 years. You know, it's giving with one hand and taking with the other hand. Doesn't bring us further, nor Estonia, nor Europe. That's the only comment I have to make before lunch.
So, Ray.
Yes, thanks, Edwin. This is an important signal from your side. I think that we shouldn't confuse the fact that these days the government and the lean officials are trying to figure out the best way to achieve the 2030 goals. So we shouldn't stay we should monopile it like that. So we should understand that the first goal is to get through the 2030, get the goal done. In our opinion, there is a place for offshore wind in 2030 as well. We'll give it a chance, no problem. We are just not trying to speed only the offshore part. We are trying to give the developers the chance they need as a whole. As for past 2030, I already mentioned, and I will emphasize it again, the goal is to have next waves of investments into wind energy, especially in offshore, to have the wind energy in our economy as fast as possible. This is the goal of the government, and this is the need that we foresee in the nearest future. Indeed, it's not so clear yet. It cannot be so clear yet because there are a few parts missing. However, the thing that Elering is already doing, this is a clear signal towards 2035, 2040. The same signal that Kriste is giving through TTA. So this is also the signal that we are trying to show the world that the investments into offshore grids, into offshore winds are welcome, and we try to make the best to have all the capacity installed in Estonia in a matter that it can be consumed in Estonia as well. Of course, we are not trying to explicitly say there could be no exports. Of course, if it's possible to export, this is fine. But indeed, point taken, we need to be a bit more clear about 2030 and beyond. Thanks.
So, any additional comments or questions? So it's lunchtime, I guess.
Indeed, it's lunchtime. See you back here in about 53 minutes. Enjoy lunch. Welcome back, everyone. Congratulations, we have made it to the final session of our two-day conference. And to bring you back, I would just like to remind you all that there was an interesting fish that we heard about in the presentation of how to build foundations for offshore wind parks and do it not to disturb so much of the sea life. And there was an interesting fish called küürimislusikas in Estonian. Apparently, küürimislusikas was translated by Google Translate, and with the original fish name being lestakala. So we now know, if you're using Google Translate, it can mix up küürimislusikas and lestakala. Maybe Google will update their translation algorithms. So the last session will once again take into focus one of the key principal questions that we have discussed. Although it's super fun to build wind parks, it's not an aim on its own just to generate electrons. You build wind farms for a bigger purpose, and the bigger purpose for society should be added wealth somehow, somewhere. And the last panel seeks to answer that question, what can you actually make of the electrons? Where can you actually generate wealth? How can you store electricity if there's too much of it at one point? Something we don't really have to worry about currently in Estonia, perhaps during summer. So I'm happy to invite onto the stage the first presenter of the final session today, Mindaugas Urbonas. I hope I pronounced that more or less correctly.
More or less.
More or less. You can say your correct name. Who's the sales manager of Eastern Europe at Enercon? Go ahead, Mindaugas.
Thank you. So hello, everyone. Pleasure to be here. So the correct name is Mindaugas Urbonas, sales manager at Enercon, responsible for the Baltic states. Living and working from Vilnius, Lithuania, and serving as the main point of contact for all the commercial inquiries and technical inquiries for the onshore wind projects in Lithuania, Latvia, and Estonia. I will start with a few facts and figures on Enercon. So the company was started in 1984 by Mr. Alois Vobin. So we are now at 40 years celebration almost. During this time, we have produced more than 31.5 thousand onshore wind turbines. Founded and still headquartered in Aurich, northwest of Germany, with the production locations spanned throughout Europe, in Germany, Turkey, Portugal, Poland, with some exclusive sub-suppliers elsewhere. As of today, we employ more than 14,000 employees. As I mentioned shortly before, installed turbine amounts for more than 32.5 units, which accounts for 61.2 gigawatts in the installed capacity. Some fresh numbers from last year. So in 2023, we have installed 628 wind turbines, a little bit more than 2.4 gigawatt worldwide. First, it was in line with our operational targets and also a 20% increase from 2022. On the operational level, Enercon is divided into the 6 regions, as you can see here on the map. And the Baltics are the part of the Central and Northern Europe region. Locally here, we have the sales office in Vilnius, Lithuania, then the Baltic service headquarters in Klaipėda, Lithuania, with the 7 service stations established in all 3 countries, 3 in Lithuania, 3 in Estonia, and 1 in Latvia. I'm missing 1 in Estonia on my slide, but yeah, we have actually 3 ones. And the service stations taking care of the daily maintenance works of the wind farms in the close proximity. Here on the left side of the slide, you can see the table with the various wind turbine types and numbers listed by the countries, what we have managed to install since 2002, the beginning of our installations here. So overall, we have 260 WECs installed with the 467 megawatts of the installed capacity. We're still taking care of the service of majority of them. Although since 2016, the markets were quite shallow, we haven't seen many new installations ongoing for Enercon. However, we're happy to say that last year, 2023, we have restarted the business here. So in 2023, we installed 2 new wind turbines in Estonia, 5 in Lithuania. Then for 2024, we have already scheduled 11 new installations in Lithuania, and then going into 2025, although the pipeline is still building, we have currently scheduled 6 more installations in Lithuania. Of course, the best interest is to restart installations in Latvia and to add more capacities in Estonia. In this part of the presentation, I will go through a technological overview of the wind turbines, component by component. To start with is a general overview. Here you can see the picture of cross-sectional drawing of our E138, EP3, E2 wind turbine. And the first and foremost to mention here is our gearless direct drive technology that we are known in the market for many years and for which we are different compared to all other European onshore wind turbine producers. So we are using no gearbox in between the generator and the hub. Therefore, our generators are large in size and being rotated directly at low variable speed by hub and the blades, basically following the wind speeds, which results in the little wear and tear for the machines due to the slow rotation. Also, due to the absence of the gearbox, we have less overall mechanical components in our designs, which then provides the extended durability of the wind turbines throughout their operational lifetime. On the electrical level, all our wind turbines are equipped with the full-scale power converters, which basically decouples generator from the grid. And then the performance on the grid is mainly determined by the inverters themselves. Due to this, our wind turbines can produce, first of all, high level of power quality, and also can show the extended grid compliance measures that sometimes is a big challenge in some markets. Going next are the nacelles, and here you can see the evolution of the Enercon nacelles. First one is the egg nacelle, which become like a trademark, iconic one for Enercon. We've built this design for more than 20 years. Although in 2017, we have switched to the compact nacelle design, which basically consists all the same components as the egg nacelle, but we removed all the unnecessary extensive parts, and due to this, we were able to save some time on the transportations and also assembly times on site. Although since last year, we have introduced the e-nacelle design, which is more or less like a market standard nowadays. And this design will be used for all the new developments for new wind turbines. And the main difference between the compact nacelle and the nacelle is the location where we put all the power electronics. So the compact nacelle design, all the power electronics were located at the bottom of the tower, and then we needed to install 48 low voltage cables to connect the generator with the electrical part. Although with the e-nacelle, now we have all the electrical parts being located directly at the nacelle, and the power conversion now is performed at the hub height. And now we need only single cable to install between the medium voltage switchgear and down the tower and the transformer. Significant improvement in the installation and assembly times. Also, what's also important here, that the e-nacelles now can be fully assembled, tested, and prepared for the installations directly at our production facilities. Then we can put this straight on the truck, as you can see here in the picture, and then after the transportation, the e-nacelle is basically ready for installation. Next, I have the generators, as I shortly mentioned before, the directly driven generators. For many years, we have used electrically excited generators, which you see here on the left side of this slide. This is the drawing of our generator from E138 EP3 machine, 4.26 megawatt, and it's 10 meters in diameter. Rather big, huh? So in order to transport the site, now we need to split this in 3 parts and then assemble it again before lifting up, which sometimes rather challenging. Although since 2017, Enercon acquired another wind turbine manufacturer, actually a Dutch company called Lagerwey. And together with the acquisition of Lagerwey, we have also acquired the permanent magnet generator technology, also directly driven. And the difference you can see here in this slide. So on the left side, up to 6.3 megawatts generator and only 6 meters in diameter. So basically we save 4 meters in diameter and win 2 more megawatts in the rated power. What's also important about the permanent magnet generator that we have acquired is the non-usage of the rare earth metals, especially dysprosium, which is being used in another permanent magnet generator manufacturers worldwide. And dysprosium can be sourced only in single point sources in Asia, which can then easily become a limiting factor in your supply chain. For us, it's not the case. All the raw materials that we are using are easily accessible worldwide, different locations, so we see no conflict with regards to the supply of the raw materials in our production. Next are the blades. Here you can see the drawing of the EP3 series blade of Enercon, equipped with the trailing edge serrations as a standard for noise reduction. We have used this design of this blade, and the design basis, same one, will be used for all the new products that we are currently introducing to the market. I think the most important here to mention is all blades of this kind are being designed and produced by Enercon at our own European production facilities. Next, I have the overview of different tower and different tower technologies that we are offering together with our wind turbines. To start with, the simplest one is the steel tower structure, where tubular steel sections are being put on top of each other. Of course, very easy structure, easy to transport, and includes fast commissioning times, although we are quite limited with the hub heights that we can reach with the tubular steel section due to the limitations on the bottom diameter of the single steel section, which then becomes hard to transport. So next in line, we have here concrete hybrid towers, where the bottom part of the tower is being made of modular concrete segments, and then switching back to the tubular steel segments at the top part of the tower. So with this one, we can be flexible in bottom diameters and also reach appropriate and needed high hub heights. Next one we have here is the modular steel towers, although we are not using this technology for new developments anymore, but this was a rather interesting one. The full tower is made of the modular bent steel plates, bent steel sheets being screwed with one another. Again, flexible with the bottom diameter, we can reach high hub heights. And also, the most important here, it's very easy to transport the steel sheets. We can reach basically any location in the world. Although this comes with a drawback that we need the prolonged assembly times to get the tower together. So the next one in line, and the design that we are offering now for the new wind turbines, is the hybrid steel tower structure, where the bottom part of the tower is made of the modular steel plates, and then switching to the tubular steel sections when we reach appropriate height. This combines the fast commissioning for steel sections with the transport advantages of the steel plates. Going next, I will jump to the products, the actual products that we're currently offering to the market. Here you see the general product portfolio. As of today, we have 3 platforms available, EP5, EP3, and EP2. Starting with EP2, this is kind of a legacy platform. We've built more than 17,000 machines from this platform. As of today, we have only E82 left, the machine of rather small dimensions, up to 3 megawatts in rated power. Although it's very well suited for strong wind sites, class 1 and class 2 wind sites. And also, we are in a good position to offer this machine for some special applications, like installation in the ports, installation at different industrial locations, and some other occasions. So we are well positioned there. Next one in line is EP3, E138 machine, up to 4.5 megawatts in rated power. This, by the way, was the best-selling machine in Lithuania for the last 2 years. I think we can fit basically any site, both coastal and inland locations here in the Baltics. It is suitable for different wind conditions. Although with the EP3 platform, we are still using the electrically excited generators that I have introduced before. And starting EP5 platform, all the machines are being equipped with the permanent magnet generators. And we currently have 2 options here. The first one is E160. 5.56 megawatts in the installed power, 160 meters of a rotor diameter. But I would like to talk more about the next one today, which is the new product that we are currently introducing to the market, and it is the E175. E175 is the machine with a rated power of 6 to 6.3 megawatts, 175 meters in a rotor diameter, best in class, by the way. Very well suited for the low wind sites, which is mostly the case for the inland locations here in Baltics, with the tower selection spanning in the range from 112 to 162 meters. The machine is available for the installation starting in 2026, Q1. This is a rather important slide, and I've heard this topic being touched upon previously today, and even yesterday. So, as you may be aware, due to the market push, many market players were in a kind of a rush to introduce and produce even higher and more powerful machine. So due to this, R&D cycles became rather squeezed. And then the topic of the technological risks became more important, especially by some market players, like financing institutions. So in another case, E175 is nothing that we designed from scratch. It is basically the recombination of the well-proven technologies that we have used in E160 and E138 machines. Recombining those in a proper way, we're ending up with the E175 design. Only 2 new things that we are introducing. First is the prolonged blade. It follows the same design basis as in E138, but now the blade is 86 meters long. And the second one is the slightly uprated generator from E160. So we can now reach up to 6.3 megawatts instead of 5.5. Here we can see the production landscape of E175. This will be mostly in Europe, produced wind turbine. The blades are being made in our factory in Portugal. Then the hub nacelle and power electronics are coming from Aurich, Germany. And the generators are currently being produced in Opole, Poland, to be extended later on to the Magdeburg, Germany. Then for the towers, we are sourcing those as per best cost basis worldwide. And then combining the European production of main components with the worldwide sourced towers, we are aiming to provide the best LCE solutions for the developers to fit their project economics. This is a timeline of E175. So first half of this year, we're building a prototype machine at the German site, with few more prototypes coming later in the year. Then by the end of 2024, we are starting serial production. Then we have full 2025 dedicated for German market. And starting 2026, Q1 machine becomes available for the installations worldwide, including Lithuania, Latvia, and Estonia. Although we have all the commercial and technical information ready, so feel free to catch up with us. Here's a little bit more about the prototype status. So this is not that's something we have only on paper. As you can see here, August last year, we already had the hub and the machine carrier ready for the prototype machine. And then in January this year, the foundations were finished at the prototype site. Then the nacelle is almost done and will be ready for the installation very soon. Also, the fresh news from last week, the first blade of E175 arrived at our testing facilities in Auric, currently being tested and being prepared for the prototype installation. So we are, I think, very well on track with this one. Going next, we understand that the 6 to 6.3 megawatt nameplate is a little bit behind from what we see in the other market players, although we wanted to be quite fast with this one, and I think we are very well on track. Although in parallel, we are working on the second release of E175. We call it E2 version of the wind turbine. It will have all the same components as with the first one, but we are introducing a new generator here. So the new generator, again, will use the permanent magnet technology. We'll reach the rated power starting from 6.6 to 6.8 megawatts, and we'll use an opposite concept that we used to see before. Now it will have the inner stator and outer rotor concept. We are working on this concept and this design since 2018 on the R&D level. Here you can see the generator on the test stand. Currently, it's undergoing its final tests and should be released to the market later this year with the installations available late 26 or early 27. Although since the generator again will be 10 meters in diameter, we need to split this in two halves for the transportation, as you can see here in the picture. Single halves of the generator being loaded on the trucks, 5 meters width and 60 tons of the mass each. However, we are adopting a new installation and assembly structure here, so we are not taking any on-ground assembly activities anymore. The new generator will be directly installed and assembled at the hub height. So we first lift single half, fix it, then we lift second half, fix it. Finally, we put on the hub and the machine becomes ready for the installation of the blades. This also comes with the advantage with a reduced weight per single lift, which allows us to use smaller cranes, which then allows us to save some costs on the overall project expenses. This generator technology and installation concept was already recognized in the market by the trade magazine Wind Power Monthly in its Turbines of the Year Award 2023. It has received a gold medal in the drivetrains category and was recognized for its separable permanent magnet technology, its reduced need for the rare earth metals, and also the innovative and efficient pre-assembly, transportation, and installation concept. To wrap up my presentation, I would like to touch upon a few services that we as Enercon provide to the market. Of course, we have a wide variety of the project development and the wind site engineering capabilities, but I would like to point out the grid integration here. As you may be aware, different power system operators in different markets provide different grid connection conditions, which are rather challenging sometimes. So for us, it's kind of hard to have off-the-shelf solution that then can fit all these different requirements. We have different add-ons and configurations that we can add on the turbine level, but we need to foresee that in very early stages. So we have the team of the grid integration specialists available, which works closely with both power system operators and wind farm owners or developers to ensure that all the offers that we are providing for the customers are equipped with all the needed configurations, which can then be in compliance with the grid requirements. This, of course, allows us to overcome some shortcomings that may appear in the grid testing phase. And last one, but not least, is with regards to the service activities. Here we can see some historical numbers of our worldwide turbine fleet, which are under full service contracts. So we've managed to reach and exceed 98% of the availability, which I think is a very good sign of the Enercon quality that we are bringing to the market. Of course, our aim and the best interest is to keep up with these numbers and to increase those even more. That was all. If you have any outstanding topics, you can catch with me on the separate basis. And besides that, thank you very much.
Thank you very much. We're going to continue our overview with new and potentially very beneficial technology with Ragnar Raudsepp, who's the head of development in hydrogen technologies at Eesti Energia.
Thank you. So hello everyone, my name is Ragle Raudsepp and I work at Enefit, also called Eesti Energia. And as already mentioned, I am a head of development in hydrogen technologies, and today I'm going to talk about hydrogen. So during this rather short 20 minutes presentation, I will first talk about the meaningful use of hydrogen, so where hydrogen should be used, and maybe some areas where it shouldn't be used. Then also briefly about Enefit's plans regarding hydrogen and challenges, especially which regards to a green hydrogen implementation. So we start with this graph. Maybe some of you have already seen it. It's called the hydrogen ladder, and it actually indicates the areas in which hydrogen will be used globally by around 2035. So if we are up on the ladder where the A is, those are the areas where hydrogen is highly competitive, and for example, the fertilizer industry, hydro generation, hydrocracking, and desulfurization, there is no better alternative for hydrogen. So hydrogen is has always been used in those areas and will be used also in the future. For example, methanol, that is also there at top of the ladder, we can react hydrogen with CO2 called the Sabatier reaction. This is one way to get methanol, but there is also an alternative, for example, biomass gasification. Now, if we move down from the ladder where, for example, B and C, hydrogen is still highly competitive. There it means it has a remarkable market share, but there are other alternatives as well, especially biomass is then one alternative use. And if we now move even more downwards, where the orange and red color is coming, there actually the hydrogen using hydrogen is not so competitive. It means that actually electrification makes more sense, which doesn't mean that hydrogen shouldn't be used, but it's rather a niche market in those areas. And what is the current situation regarding hydrogen globally, so where it is used and how it is produced? So in 2022, around 95 million tons of hydrogen was used. And you can see in this pie chart there how it is divided. So 41 million tons was used for refining, so mostly then fossil fuel refining, 32 million tons for ammonia production, 16 million tons for methanol production, and 6 million tons for metal industry. And out of this 95 million tons, less than 1% was actually produced with low carbon methods. So most of the hydrogen is produced via methane steam reforming. And by doing this, each kilo of hydrogen produces 10 kilos of CO2. And another really method that is used to produce hydrogen is also then coal gasification, which also produces high amount of CO2. So now if you multiply this 10 with this 95 million tons, you will see actually how much this hydrogen economy currently is polluting. So what we need to move towards green hydrogen. But green hydrogen requires excess of renewable energy. And excess, I mean that we first need to cover our needs, so the electricity that we need with the renewables, and the excess of this we can use to run the electrolyzer and split the water, so produce hydrogen. And this excess renewable energy also goes hand by hand with the lower electricity price mostly. And by producing hydrogen with the lower electricity price, it also makes it more competitive with the hydrogen produced with fossil fuels. And here is also a small example of the electricity day-ahead trading prices in Estonia last year. So on the x-axis you can see the 2023 timeline, and on the y you can see the price, so euros per megawatt hour. And we can see that there were already many hours in June, July, and October where the price was even negative. And this is expected coming more in the future, because we will have more renewable energy. So, and to avoid those negative prices or shutting off the PV park or a wind turbines, we can actually use this extra energy to run the electrolyzer and splitting water by it, producing hydrogen. So here I turned the line. It doesn't need to be a negative price, but it can be a low price, so maybe around 30 or 50 euros per megawatt hour. But this price actually depends also on the particular project and also the off-taker of the hydrogen. So what should be, what is the feasible price for the hydrogen? So now briefly about the Enefit's plan regarding hydrogen. So Enefit is actually producing hydrogen for more than 50 years. So we have electrolyzers producing hydrogen, and the hydrogen is used to cool the generators in the power production units. And with the capacity of those electrolyzers, we are actually able to produce 30 tons of hydrogen yearly. So if we would use all the current wind energy in Estonia, which is currently available, we would be able to produce 10,000 tons of hydrogen yearly. And if the Liivi offshore wind farm will come into operation, then 80,000 tons hydrogen per year. Of course, those are theoretical numbers. That means that we should really use all the wind energy to produce hydrogen, which will never actually happen, but just to show the dimensions. Another project which is now ongoing, so Enefit Green is putting up a 0.5 megawatt electrolyzer, which will be connected with the hybrid wind and PV park. They produced hydrogen, Alexela will use it. They were going to build 2 public refueling stations, one in Tartu and one in Pärnu. And GoBus is going to have 3 hydrogen buses. So this project, as I mentioned, is ongoing, and it should be ready already 2025 September, so next year. So it's a pretty short deadline. And this is so this project, it's a small pilot project. This is a stepping point for Enefit to a hydrogen business. So another project which is in the planning phase, so hydrogen-ready gas-based power plant should be commissioned earliest 2029, consuming 1,500 tons of hydrogen yearly. And this 1,500 tons hydrogen yearly, this is a 30 volume% of the gas blend. The rest of it is methane gas. And to produce this amount of hydrogen yearly, around 15 megawatts electrolyzer is required. And this hydrogen-ready gas plant, this allows us also in the future, if we have more green hydrogen, to increase the amount of hydrogen in the gas blend. So we can actually go to 100% of hydrogen. Those images here, they are from Siemens Energy, but we don't have a particular manufacturer yet for the gas turbine. So we are currently exploring what the companies are offering. And a little bit also about the chemical industry. So Enefit is currently using oil shale rock, shredded tires, and also in the future we're going to use waste plastic. We will pyrolyze it, we get electricity and also liquid product. And one part, so rather small part, around 15% of this liquid product is a gasoline. So it's called oil shale gasoline. And currently this is a low quality gasoline. It is sold to third countries, and it is not actually really beneficial for both sides. So it would actually make sense to treat this gasoline with the hydrogen and to convert it to a feedstock for a chemical industry where then various products can be done. And then at the end of the lifetime of those products, they end up again in this shredder, so the cycle will start again. And for this, we need around 5,000 tons of hydrogen annually, well, starting at 2030. And the largest part of this liquid product is actually heavy oil. Currently, this heavy oil is used as a fuel for ships. But again, we could actually add more value to it by treating it with hydrogen, making it a feedstock for a chemical industry, and make various products out of it. This is actually the largest part of this liquid product, and for this, to treat it with hydrogen, we need 22,000 tons of hydrogen yearly. And we are also making CO2, so we also need to do something with the CO2 that is coming out of this system. So one possibility would be then to react this CO2 with hydrogen, Sabatier reaction, and make methanol. And for this, we need 64,000 tons hydrogen yearly, starting from 2040, but it doesn't mean that it could also start earlier. But this just indicates that only for the benefit for this particular case, this chemical industry, we need around 100,000 tons of hydrogen yearly. So what are the challenges regarding hydrogen, especially green hydrogen? So the production cost of green hydrogen is a problem, and this is highly affected by the green electricity availability and price. For example, I have now here the numbers from 2022. So in Estonia, the green electricity production was around 2.6 terawatt-hours, and the consumption was 9 terawatt-hours. So we don't know exactly what will be the electricity consumption 2030. But we have already heard today that 2030, actually, the electricity from Estonian grid should be all renewable. So we have still a long way to go. And the second parameter what affects the green hydrogen price is the electrolysis efficiency, and the third is actually the cost of electrolysis itself. And the losses are high for the hydrogen production, and the expectations to research is to increase the efficiency of the electrolyzer and also to increase the flexibility so it can adapt better with the fluctuating nature of renewable energy, and also to reduce the cost of the electrolyzer. And last but not least, also the efficiency of hydrogen electricity. So if we compare it with the newly installed cogeneration plants in the EU, so now I'm not talking about hydrogen, but in cogeneration where something is burned to get the heat and power, so the efficiency is up to 90%, and the electrical efficiency, it varies between 30 and 55%. Now, if we look at the hydrogen cycle now here, we start with 100%. In the next step where this grid is, we lose a few percent. And then come the electrolyzer, which has the efficiency 40 to 60%. If we use the heat, so the arrow up, then the efficiency is around 80 to 90%. And now we use the fuel cell to convert this hydrogen back to electricity. So if we look at only the fuel cell, then fuel cell efficiency, so electrical is 40 to 60%, similar with the electrolyzer. And if we also use the heat, then it's 80 to 90%. But if we now take the whole cycle, from starting with this wind turbine, then the whole electrical efficiency is 20 to 30%, and with heat utilization 40 to 45%. But yeah, so this is also something that needs to be worked on. Of course, I have to mention that this 20 to 30%, the lowest efficiency, it is still the efficiency that now the internal combustion engines have, and we are okay with this one. So yeah, and conclusion. So hydrogen is unavoidable in the industry and the value adding in maritime, jet aviation, long-distance, heavy-duty transport sectors. And so currently, the hydrogen comes mostly from the fossil fuels. And the bottleneck for the green hydrogen production is the availability and price of renewable energy. And also a really nice image. This is from Germany. There is then the electrolysis plant is then connected with the hybrid PV and solar park. Yes, and that's it. Thank you.
Thank you for making clear what hydrogen is and what it isn't. I'm happy to invite now onto the stage our next presenter, who is Andrus Savvatskis from Utilitas Wind.
Oh, such a spotlight. Yeah, good afternoon, dear friends. And Edwin, I don't see if he's here. During those 2 days, it has been lots of talk about the wind power. So I would like to now try to speak about how wind power can be used in different sectors. So I'm talking about sector coupling on an example of what Utilitas has done. As mentioned, so yeah, most of you probably know me already, but for those who do not yet, then yeah, my name is Andrus Savvatskis. I'm the member of the board acting as a CTO in Utilitas Wind, and then I'm also a member of the board in the Estonian Society of Electrical Power Engineering. Due to the fact that I'm by education, I'm a power engineer. Greetings to Ivo. Then, yeah, about Utilitas at a glance. So Utilitas is the largest renewable energy producer in Estonia and the largest wind energy producer in Latvia. Utilitas, as most of you probably also know, that Utilitas is originally a district heating company and has been in district heating for already more than 10 years, more than 15 years, I believe, or more than 20 years. And has some 20 million square meters heated buildings, which is 5,600 buildings, which means that more than 400,000 inhabitants are supplied with environmentally sustainable district heating. Last year, Utilitas produced 2.4 terawatt hours of energy, and from which 2/3 were renewable. The total capacity of heat and electrical capacity is 1.4 gigawatts, and we do have 118 megawatts of wind up and running in Estonia and Latvia. So, as my topic was sector coupling, sector coupling is a transfer of clean electricity into other sectors, where it's used to reduce the amount of required fossil energy. So, which means that all the electricity produced, for example, in the wind power, can be utilized, for example, in the heat sector or in the transportation, etc. Shortly about the background. So energy demand in Estonia is currently, so you see the typical graphs of the heat demand, electrical demand, and the transportation fuel demand. So one or half of the energy consumed in Estonia is used in heat production. Quarter of it is used in, roughly quarter of it is used on electricity production, and the rest, 25%, is used in transportation. Heat peak demand or heat peak load is approximately 10 times higher compared to the low load period. And then, of course, as you see also from outside today, then during the winter time there is a peak load, and during the summertime there is a low load. The same is for electricity. So, but in electricity the peak load is 3 times higher than the low load. So electricity, we see the Ministry of Climate is preparing the new National Energy and Climate Plan, which, or refreshing it, so to say. And we see that in the work version, there is a electricity demand forecasted in 2030, it's decreasing. The heat demand is slightly increasing, and we see also the decrease in the transportation sector. We actually do not understand from where the decrease in the electricity sector is coming. So we see that as we take roughly today's consumption is roughly 10 terawatt hours, then if we add 2.5 terawatt hours of heat produced through electricity, and then some additional 2.5 terawatt hours of transportation, which is transiting from fossil fuels to electricity, then we see already that it has a potential of 15 terawatt hours annual consumption. And then if we add in there, probably in the next presentation, we see also that there is a potential of additional industry, which is up to 6 terawatt hours, then we see more than 20 terawatt hours of annual consumption in Estonia. And then if we compare with our lovely northern neighbors, then they are definitely not so humble in forecasting their electricity production numbers for 2030 or 2035 in Finnish case. So the Finns are forecasting the increase of electricity consumption even 72%. Swedes are forecasting almost 40%, and the Norwegians 27%. So whereas Estonia is forecasting a decrease. If we divide the annual electricity consumption based on the 1 million inhabitants, then current Estonian consumption is 6.9 terawatt hours, whereas Finnish is almost 16, Swedish almost 14, and then Norwegian almost 26. So, and then to put it into the proportion, then the Estonian expected, or let's say compared to the Finnish electricity consumption per capita, Estonian consumption could be around 20 terawatt hours, which means that the additional industries is needed very much in Estonia as well. Utilitas pathway to carbon neutrality. Utilitas started its transition towards the carbon neutrality in 2008, and then in 2022 we had almost 2/3, or a little bit more than 2/3 already produced from renewable energy sources, and whereas the carbon intensity has been decreased from 200 grams CO2 per kilowatt hour to 72 grams CO2 per kilowatt hour. So Utilitas' goals for 2030 are to deliver carbon neutral heating and cooling energy, and also to generate only renewable energy. So sustainable energy solutions. So what are those? Sustainable energy solutions are the solutions which allow customers to consume at the desired moment, at a reasonable price, and environmentally friendly energy. And then for this, so that's the current energy production complex in the eastern part of Tallinn, in Väo. So where Utilitas has two 25 megawatt CHPs, and then the 950 kilowatt of solar park as a combination. But in few years, it will be transferred to an integrated energy production solution where additional second stage flue gas condensers, heat pumps, and electrical boilers will be added. Then hydrogen production and refueling station will be constructed. Both of those are already under construction. And then tracking PV park with a capacity of 10 megawatts will be constructed also by the end of this year. And then additionally, heat storage with a capacity of 100 megawatts, and 900 megawatt hours will be added by the end of next year, beginning of 26. So green hydrogen. So as I mentioned, so in Väo, the green hydrogen production unit is already in the construction. The total capacity is 1 + 1 megawatts. So that means that in the first stage it's 1 megawatt, plus in the second stage it's additional 1 megawatt. The first stage will be ready by the end of this year, and the second stage will be ready by the end of 2026. This allows us to produce 130 tons of green hydrogen, and additionally, 2 green hydrogen refueling stations will be constructed. And this is the complete green hydrogen value chain project managed by Utilitas, and then that's the first one of its kind in the whole Baltic states. And what is the advantage there is also that as it's located, the hydrogen production is located next to the district heating network, and then the CHPs, then all the heat produced, or well, not produced, but all the excess heat from the hydrogen production will be also used in the district heating network. And as this is a complete project, then the refueling stations will be done by Alexela, and then 30 Toyota Mirais will be bought and will be operated by Bolt. So next developments. Wastewater heat pump will be constructed in Tallinn wastewater treatment plant. And the seawater heat pump will be installed by the sea close to the Tallinn city center. So the wastewater heat pump will utilize the heat of wastewater, Tallinn wastewater, which is collected in the Paljassaare waste treatment plant, and then transfer it back to the process. And then seawater heat pump is heating during the winter time and then cooling during the summertime. And that effect is that the use of the heat pumps allows utilities to reduce the share of fossil fuels less to than 10% of the total energy consumed by 2027. Whereas 500 gigawatt hours of fossil fuel per year will be avoided. And then the reduction of CO2 emissions by at least 100,000 tons every year. And yeah, I can't do my presentation without talking about wind as well. So, and then currently Utilitas is operating 3 wind farms, as mentioned before. The largest one we have in Latvia. It's located on the western coast, close to the city of Ventspils. It was constructed. The construction was finalized in September 2022, and it consists of 14 Vestas V136 turbines with a tip height of 150 meters and with an annual production of 155 gigawatt hours. Additionally, if you're talking about Latvia, then we are owning and operating there a Grobina wind farm, which is basically the first big wind farm in Latvia, which was actually constructed 20 years ago. But thanks to the technology, thanks to the turbines and the technology which is up and running there, which is the Enercon technology, then the turbines have been running very, very fine. And then also they are more than 20 years old, so they are still running quite fine. And then just recently, we have also finalized the construction of Saarde wind farm in Estonia, our first wind farm with 39 megawatts, and which is consisting of 9 Vestas V150 turbines, tip height 230, and annual expected production is 135 gigawatt hours. So, as mentioned, then at the end of last year, we had in operation 118 megawatts. But the goal to 2026 is to have 600 megawatts onshore wind farms in operation throughout the Baltics. 600 megawatt onshore wind farms with permits and 1.2 gigawatts of offshore with permits. That's it. Thank you very much.
Thank you, Andrus. So what do we do with the electricity that we produce? Joonas Vento from Invest in Estonia has a few ideas and I guess a few companies that could make good use of it. Joonas, go ahead.
Thank you very much and good afternoon, everyone. I see the slide here. Can't see it there. Probably you would like to see as well. Maybe somebody needs to change it. Yeah, thank you very much. So my name is Joonas Vento. I'm the head of Estonian Investment Agency. The agency belongs under the roof of Enterprise Estonia or EAS and then KredExi ühendasutus as in Estonia. Our goal is to attract foreign direct investments into Estonia and then the foreign companies to actually do their business in Estonia as well. And of course, we have mapped out and greatly put together the advertisements and then the value propositions about what Estonia actually has to offer. And through the slides today, I can show you that the interest towards Estonia and then coming here to do the business and then actually bringing their investments into Estonia is huge. And I'm, of course, glad about it. But we didn't agree on the slides what Andrus put on the screen today, but I'm really glad because the messages from my side are the same. And we can go into those details further as well. But what's our goal? Our goals are not that just to bring millions into Estonian market and actually maybe build up the contest here or competition to actually fight the Estonian capital. Our goal is to actually boost the Estonian economy through that boost from that foreign direct investments. And of course, the whole idea is that we don't like to attract all of the investments, all of the companies here, but we try to bring out the criteria which are actually from our side prioritized. So definitely knowledge intensive and capital intensive investments, but the clause is that they need to be the highest value added investments possible, which they do in Estonia. And of course, they need to be with the huge potential for exports. And of course, it's good that they will create jobs through the investments here, so that the Estonian people will find new and high-paying jobs. But until this time, we have advertised Estonia as a great digital nation, which it definitely is. But what next? And then I see a great transition in the energy sector, which definitely helps to solve the what's the new message which we bring to the world, because Estonia is well seen right now with the value Estonia has to offer. But could it be the modern and the innovative industry based on green energy? I definitely hope so, because we have plenty of it and then we need to value it. But Estonia valorizing the energy Estonia has done quite a good job. The GDP per capita compared to the energy needed to actually produce that GDP here, we're at quite a good spot on it. But if we benchmark it to Denmark, which is the highest, the most competitive economy in the world and the most competitive country in the world in that view, then we definitely need to develop or get our legs from under our bellies to actually start sprinting. I'm not going to stay on that slide that much. Probably I have already the wrong numbers as well, but the message is clear. We have we need to boost the energy consumption per capita definitely, that we could be more in a competition with our neighbors, because the view for energy consumption prognosis in those countries are definitely with a bigger ambition than ours. And the message or the point of the second point here, that the consumption with compared to Sweden and Finland and Norway, for example, is that the starting ground is way smaller than theirs. So definitely we should have more ambition to grow that energy consumption. Yeah. Now, the valorization of workforce versus energy. We all know that Estonia is a really small country with the employee amount of around 800,000 or something like that. And we understand that the migration laws and then the criteria around that topic is definitely not that open to foreign talent here as well. Of course, it has developed in a better what's the good word here? Destination. But definitely it's more easier to actually develop or plan the energy production in Estonia. And I'm glad that there has been so many people in this room whose actual goal is to have more green energy in Estonia. So a little points or overview about our pipeline as well, because around 35 successful projects per year we have had in the last, I don't know, 5 years already. And then the last 2 years, for example, around 350 million foreign direct investment all in all as an amount came to Estonia through our help. But this is the future glimpse or the view to the next projects. The brownfield investments or the continuing investments we see in a short term in the next couple of years, which probably will be successful and will be coming out of to the spotlight, that these investments will be done here in Estonia. So I also put the potential electricity needs under it as well to support those messages from Andrus as well, that actually the energy production needs to grow even further. And also the large investor investments in the short term, in half a billion investments potential in our pipeline, and also almost 1 terawatt hour consumption in the future in the pipeline as well. If we take the midterm and then even further from there, we see billions of potential investments coming towards Estonia, but it needs to have the criteria met which Estonia has to offer. So definitely green energy is in the discussions around the table if we speak with the potential investors, because we see it already from the exporting companies of Estonia that some of the markets are already closed if you can't put the ESG policy on the table and say that and prove that the production or the services are being done with a green energy. This is a little bit like a bigger portfolio, and then probably some of those projects are off the table already as well. But in a couple of slides, I can show you the pipeline, how actually we do work and find those potential investments. But on that Excel, we can see that the potential investments are in billions, but the need for that energy is almost 8 terawatt hours in the making. So definitely, I can agree with Andrus that we can see the 20 terawatt hour consumption in Estonia for the future could definitely be more right. Now, the standard for us is that if we compare the projects and if we analyze those projects, and we do understand we need to prioritize those in the making, we analyze the economical impact to Estonia's GDP and then, of course, the state budget as well. We did a couple of months ago already a socio-economical impact report on 12 companies or 12 projects. And the outcome of it was 1.4 billion of investments. But it showed that only from the building phase or the first 2 years, the outcome for the state budget, for the GDP, was 500 million, and then to the state budget it was 90 million. All in all, with the first years of production of those projects, and then if they already start with producing any goods in Estonia, we saw that the impact towards GDP was 1.1 billion or 1.2 billion, and it meant 4% of the GDP growth. We have seen GDP going at the wrong direction right now, but it could be the potential outcome for Estonia to actually attract really high-valued projects into Estonia. So this is the sales funnel, how we do work. We say that we are as like a sales team for Estonia, selling the economical environment here, and it's definitely a good project a good product to actually sell. We do work through around 1,000 leads a year, and that means that they will evolve into around 500 projects, and around 150 visits will come to Estonia because of that, and around 35 successful projects will come out of that funnel. So we do understand that we need to broaden our vision to find more leads and more interested parties from everywhere in the world, so that we could have more potential and high-valued projects here in Estonia. I tried to analyze yesterday what could be the perfect storm to actually land the FDI, because all of the countries, our neighboring countries, and all of the countries actually in the world have agencies like us from the governmental side, also from the private sector side, and all of those countries, all of those regions actually have a competition for those investments, because as I already said, those investments lead to new and high-paying jobs and like new evolving regions, maybe not in Estonia, but all in Europe. Definitely, our new goal with the new strategy we wrote last year is that we try to attract foreign direct investments through value chain value propositions. That means that we do need to understand what that Estonia already has, value chain based, what kind of sectors, what kind of stakeholders or companies are already here, and what kind of next steps in those value chains are the opportunities actually for foreign companies. A great example is the magnet factory, new performance materials, which is being built right now in the eastern part of Estonia. One of the biggest value was that actually Silmet with the the knowledge and the valorization of rare earths, earths are already there. So the next phase was logical for the magnet factory. Now, it opens up so many different opportunities for Estonian companies and foreign companies as well. Electrical motors, wind generators, any power pumps. It's needed as we saw from the Andrus's presentation as well. So that are definitely the possibilities. The base criteria is that it needs green energy, because the electrical car, which is the motor and then the magnets inside, are being produced by, for example, oil generated power. It will not sell in the future. And I think a good example from last year, also one project which went to Pärnu, Põhja-Pärnumaa vald, was the smart power farm. We had our help in that project as well a little bit, but it was all of those criteria were met. They needed 100% green energy, which Tootsi Wind Park will produce quite soon, and they also needed the support from the local municipality. So we turned NIMBY into YIMBY, and then the local municipality welcomed them in open arms. We had green energy, we had local municipality support, and we had a lead from Sweden a year ago. So all of those criteria were met, and then the stars were aligned, and we saw 100 plus, and then maybe more in the future investments coming into Estonia. So yes, that's how actually we need to map out and see what Estonia has to offer, and then where does those green energy and then wind parks and solar parks come. So I think that's a good time for a message that all of the developers, please let us know as well, because we can help with you with the outtakers, which is definitely needed to guarantee those projects to be successful. But we definitely need to use the momentum we have right here. I'm really glad to hear the speakers on stage speaking more with a stronger voice and with a guarantee that stuff will happen. And we have more of a power to actually say to the projects we are dealing with that, yes, you will have green energy from this side of Estonia or this side from Estonia, so choose which side you would like to pick out. And definitely I see that the green energy is the most important competitive edge as a country right now. And I'm quite glad that Estonia ranks quite high in Europe for the developments and the productions already in the working for green energy projects. But I think, as we already have discussed here today as well, that we need to speed up even more, because that opens definitely up opportunities for Estonian companies in that value chain as well. Yes. And of course, what happens with that green energy and how we actually value it? If there's an spillover energy effect, then definitely we can't only produce hydrogen. We need to fill out the next spots on that value chain as well. And then I definitely hope that we are not going to export electricity, for example, in the future. We need to value it here so that the GDP could grow, and the salaries in Estonia would grow, and then the wealth will stay here in Estonia. So yeah, these are only some of the possible outcomes which I have already mentioned here today as well. So yeah, thank you very much from my side.
Thank you very much, Jonas. I don't think you have to go too far because this wraps the presentations, and it's now time for the panel. And for the panel, I'm pleased to introduce the moderator, who is Mihkel Annus, the director at Estonian Renewable Energy Association. So perhaps we can move this podium. I don't know if I'm going to do it. Will it? Will I break it? Let the professionals handle it. So the panel, please welcome on the stage.
Can I sit here, Terje? Thank you. Good afternoon from my side as well. As Jonas already said, my name is Mihkel Annus. I come from Estonian Renewable Energy Association, and we are a representative of the whole of renewable sector in Estonia. So not only wind, but others as well. But of course, Terje, with your association, is one of our biggest friends and our members. But I also have to congratulate our panelists today, because you're one of the bravest people here with the audience as well, because it's the second day and this is after lunch, so you deserve a silent applause.
Just before the end of the conference.
Exactly, so you're sitting at the most uncomfortable chairs. But just to maybe energize you as well, maybe just let's stand up for a moment, and then let's try to reach the windmill that you want to build. Maybe use the second hand as well. Yeah. And now you can use your hand as a blade. Okay, no. Doesn't matter. Thank you, and hopefully the next approximately half an hour, maybe we have more. Please also, I want to use you later on as in the last part of our discussion. Please memorize 1 or 2 questions. I will come back to you. If you have typed it down in this platform, I'm currently not able to see it, but please memorize it, and Terje will later on help with the microphone and reach you. But however, the topic of our panel today is: how does wind energy reach the consumer? Of course, we had Elering here, and they would also say that, okay, we have this cable, and this is how the energy would reach you. But I personally like to think otherwise. You mentioned that energy can reach via the industries that provide different services and materials. Also, you discussed heat, etc. Am I on the right track here? What do you think? Whoever wants to start. Maybe we will start with Jonas.
Yeah, of course, the short and the most easiest answer is through a cable, but that's not the destination we want to go. We need to understand as a country, and we need to say it out. Why do we need that energy? And which sector we do need to prioritize, where is the highest added value in it, where is the highest salaries in it, to have the workforce for it. So it opens up like a Pandora box of actually, and then we need to align the actual visions in front of that energy topic, because yes, we do understand that the economy needs green energy, and then we are competitive for it. But yes, what's the next step? What do we need to actually use that energy for?
Sure. Ragnar?
Yes, I completely agree what was mentioned here and what was mentioned also before, that electricity, for example, and also some, for example, hydrogen, that we shouldn't export it, but we should make products that are more valuable and export those. For example, yes, if we take this extra energy, we run the electrolyzer, we have the hydrogen, we can make feedstock for the chemical industry and export those kind of products.
Andrus, how would the energy reach me?
Reach you. The energy just reached you and once as you were
yes, I put my hands up as well.
That's how you got the energy. But definitely, so as I showed on my presentation as well, then there are different means of energy reaching the consumers. So as true okay in the cities, so where there is a district heating, so it's also through the electrical, mainly overhead lines, not the cables actually, and then through the heating pipes, then through the hydrogen, as we mentioned here with Ragnar as well. Then there are different means how the, let's say, wind energy can reach the consumers.
Mindaugas, you're the wind energy professor here.
It's more a topic for other guys here, of course. From my perspective, I would say how the energy reaches the consumers. I would turn this around. I would say it reaches whoever pays most. Because in order to enroll, the saturate market and if you want to build more and more renewable assets, we need to think about really paying those off at first before starting any other businesses out of it. That's the main idea. So I think that's really important. If the consumers, they'll, as you are, for example, would pay more, maybe we'll build more wind farms. Yeah.
Thanks. I would actually like to maybe start off with a question that was asked in the very end of last panel, because I heard from lunch from many people that the last panel was too short. It was very, very interesting questions, very interesting topics, and we wanted to carry on. But maybe I will ask you the best answer you can give. The last question was that, do you think that the plans currently that Estonia has, the Estonian government has, are sufficient to provide us with everything that we have discussed here for the last 2 days, actually? Maybe you have some thoughts on that as well. Andrus, maybe you can start. You are already
I was expecting it, actually. Yeah, definitely. So, if you have put the question so straight, so I have a straight answer as well. So I think the Estonian state doesn't have ambitions. So it's very, very low. They are trying to keep as low as possible, and it doesn't have guts to make the decisions.
Ragnar, you're nodding.
Yes. I mean, actually, I don't have anything else to add it because I completely agree with this. Yes, we have this goal that 2030 the grid should be green, but this is no specific guidelines, regulations. So, yeah.
Of course, Jonas, you're not a wind park developer. You're not producing hydrogen in Enefit.
I'm a public sector.
Public sector, so you have a different position. But
I need to definitely choose my words here. But of course, I mean the main pillars are set for where Estonia actually needs to develop in its economy. The R&D and the entrepreneurship. Arengukava, what's it in?
Development plan, let's say.
Development plan. It actually shows some of the like direct lines where which sectors we need to like develop more. But of course, it's a little bit broad. So it's definitely for the economy and then the stakeholders in it. It's a little bit maybe vague to understand what are the priorities in an Estonian economy. So. My wish is that we need to say more out directly yes, this is the really high added value sector we need to prioritize. There has been messages on that side as well, but it's there are a lot of news, and then the next day are new news already. So it's a little bit difficult to maybe find the right messages, but. For example, in our strategy, we try to go a little bit more straight to the sectors we need to prioritize. Like, for example, of course, the ICT sector, which is actually covering all of the other sectors as well. We need the digitalization in the industry or manufacturing as well. And that, of course, the automatization and digitalization also boosts the energy consumptions, which support the messages we just gave out as well. But like the valorization of our what's inside our Earth, because the Minister of Climate quite recently set out that we need to actually understand and how actually the materials inside our Earth core can be valorized. That's a great idea to go, but of course it needs industry and it needs green energy to do it as well.
Can I just follow up on your ideas? So, do you think that Estonia needs a specific strategic or industry strategy to develop energy-intensive industry as well, together with ICT and etc.? Or do you think otherwise?
I think so, yes, because as I said in my presentation as well, that we can't plan or grow our talent or workforce critically. It's just not possible. The society will not accept it. But we can plan the production of electricity and actually use that electricity to valorize something. So it's easier actually to do. But of course, I think we're at the right track of saying out that we need that amount of energy and that amount of energy. But then I think the next step is that how we can actually use that energy and what for now.
Yes, Mindaugas, not to leave you out of the discussion about Estonia, but how do you see as a foreigner coming here also, but dealing with wind power? How do you see this current situation in Estonia, and maybe also use a mirror and also tell us what is actually happening in Lithuania as well on this the same parallel topic?
Yeah, first of all, I agree with all the panelists, and also I'm a fan of the ambitions to reach the neutrality by 2030. All is good with this one. And you are right, in Lithuania, I think we are more or less all the three Baltic countries are going the same direction, are following the same path, I would say. But I will play a little bit of a devil's advocate here.
Good. It's a panel, so.
And also, I heard this idea yesterday. All is fine with ambitious goals and reaching the neutrality and the full renewable energy consumption by 2030. But on the other hand, I think we should aim and do our best to saturate the market with the best possible LCOE solutions, so the lowest cost solutions, which is, of course, onshore wind and PV currently. So I think that should be more of a focus, of course, because at the end, somebody needs to fund those big projects, like for example, offshore ones. Somebody needs to take the risks, and the investments are huge needed there, which in the end will be paid by the mostly taxpayers, right? The same goes for not only for Estonia. We're seeing more or less the same in Lithuania, although the offshore plant capacities are lower. But that will be one of the points from my side. Yeah.
Thanks.
If I may add,
Sure.
so as I've been in the wind business since 2006, actually, and then I've been acting in different countries in the Baltics, also in Lithuania. So I think, as we saw, let's say 10, 15 years, Estonia was the kind of the front runner in the wind sector, and then Latvians, they haven't done much even lately. So
sorry for every Latvian that's watching this.
Luckily, Utilitas has built the biggest wind farm in Latvia. So.
Great job.
But in Lithuania, it actually started to pick up approximately, let's say, a little bit more than 10 years ago. And then there has been kind of clear vision how to do it. They had first also the feed-in tariff, then they moved to the auction system, and then it almost reached to the market-based wind energy production. But of course, then all kinds of COVID crisis began, then the war began, and then environment, the economical environment changed a lot. And then now, of course, as let's say last 10 years, the money hasn't had any price. But now money has a price. The supply chain costs are much, much higher. And then yeah, it's not possible to dream about market-based wind energy production anymore. So when I joined Utilities in 2019, I was also dreaming, okay, the market price is approximately 40-45 euros per megawatt hour, and then it's near market. That wind energy can be built on near market terms. But currently, yeah, we do not see the possibility there.
So your dream has not fulfilled? Come
true.
It's not a nightmare though, no? Okay.
Not yet. Let's see how it continues.
Yeah, to stay on the wind topic for a little bit more here, also I would like to see this from the technology perspective that I also introduced in my slides. So if we're speaking about years passing by and new technologies appear in the market, so if we let's speak 10 years ago or so, the wind turbines were of the smaller dimensions, more applicable to the strong wind sites. Everybody was chasing those coastal locations to build the wind farms. As the years go by now, we see all the those big and powerful machines that we see in the market. Actually, all of those are suited for low wind sites. And you can harvest more and more power within the locations that was unavailable before due to the absence of the correct technology, correct machine, and so on and so forth. And here in the Baltics, we still have plenty of locations that we actually build the onshore inland wind farms. And again, as the technology develops, there are more and more suitable options to go further. So that's also really important to mention. And again, I really support the idea with the current situation, the free market mechanism is not that great anymore. I think going further, we will see different options appearing in the market. I've already heard today the CFD schemes being discussed. So I think this will become not unavoidable, but at least of a really important topic in the coming years. Sorry.
As far as we are currently in the technology topic, I wanted to ask you as well, before earlier on in the Dutch panel, we discussed the maximum capacity of a single turbine. You were here.
You need to guess now, yeah?
Yeah, no, I don't want to guess, but what are your insights on this discussion? I think you overheard it this one as well.
There were some good ideas told in this discussion, and I would agree with those because we cannot grow with the sizes in wind turbines forever. The manufacturers, also us, needs to harvest the money, harvest the profit out of the product they have developed. So I think it should flatten, and we should stay at least for some years on the machines that we have currently and that are coming to the market in the next years. About the maximum one we can go with the onshore, I'm not really sure. I would question if that's needed. I think we are quite advanced today, although if you look at the Chinese players, they are currently speaking about 10 megawatts plus onshore machines. Sky's the limit, but again, I would look at this more from the economical perspective. We need a healthy ecosystem for the manufacturers of the equipment.
I would want to bounce this similar question to you, Andrus, as well, because you have a technical background in wind development as well.
Yeah, okay, in the morning panel, in the Dutch panel, so it was discussed about the offshore wind turbines, so the maximum capacity of the offshore wind turbines. So I would also, okay, I hear some rumors from the market that there are some turbines with a capacity of 20-21 megawatts already in someone's heads, but yeah, do they realize? So that's the other question. So that's also true, which was also discussed during the morning panel. So that's if you look at the balance sheets of the OEMs, then we see that all of them are struggling currently, and yeah, we definitely need to have the how to say the kind of the mature product in order to give also the possibility for the OEMs to reach the profitability again. So if you're talking about maximum onshore capacity, yeah, as Minda was mentioned, then Chinese are also dreaming about 10 megawatts, but there I wouldn't say the capacity is the limit there. The physical parameters are the limit. So for example, the length of the blades. So the length of the blades is already so long that the transportation is very, very complicated already. So that sets the limit. Offshore it's a bit easier. Also with the bigger turbine gets, the bigger the vessels have to get, and then also it makes the whole the supply chain has to change.
Thanks for the insight. We have already discussed a little bit about, or the term competitive edge has been floated around yesterday, also today. But not only for Estonia, but this region as a whole, all the Baltic states, maybe we can expand it to the Nordic countries. But is it more about gaining a competitive edge? I mean, going 100% renewable. But is it a basic hygiene? As Joonas, you mentioned that many industries already expect to have renewable energy available. What do you think?
Definitely. It is a hygiene thing already. Or maybe in a theory. But it will be in the next 10 years. Probably all of the, for example, investments coming from other countries, it's the criteria. Do you have green energy or not? Could I have it without the grid or not? And then comes the incentives or anything else, logistics or transportation, etc. But I think a good example comes in a helping hand here is how Finland is actually communicating the vision and then communicating the next steps. Of course, any wind park is not finished there. There will be tons of those wind turbines being built. But they have already said, in the next 10 years, there will be 80 billion investments going into industry. 55 million from it is going into offshore wind parks in the Botnia Bay. Nothing's being built. Probably even the legal system will not accept it right now, but it's already being outsaid. So that's the vision. And if you have the vision, you can already start aligning after that. I think after that communication message came out, there has been quite some big projects being communicated from Finland as well, like a couple of billion being built, the green steel plant. Mm-hmm. Yes, but it was done because of the vision communication and message that the green energy will be here, and we will have it as a competitive edge as a country.
So this is missing in Estonia, this clear vision?
I think it needs to be said out loud more. Yeah, definitely.
I want to expand on that. Is there anything, you are obviously in connection with what you showed on the slides with different interests, let's say, that are interested in coming to Estonia. So what are their questions and also messages to us? What do they expect? Do they expect this vision or something else as well?
There are a lot of criteria how actually the investment decision is being made. And then usually, if it's an international company who would like to see Europe as the destination for their investments, or the region like Northern Europe, for example, there are usually long lists of countries they are choosing from, and then there are short lists and taxation system, bureaucracy, indexes, and then there's of course energy, and then how can I get that energy for my company? So those criteria are, there are a lot of them. Estonia definitely points out in the taxation system. By OECD, we have been like the best or the most competitive, has the most competitive taxation system in the world for I don't know, 10 years already. It's good, but now with the green turn, more and more the green energy question comes to the table at the first criteria already.
Sure. Ragle, you mentioned that most of the hydrogen currently is not renewable, or it's used basically, or the methane is used basically. When will we expect this kind of transition to realize in hydrogen economy?
When we have enough renewable energy, so this is the bottleneck, because currently, I mean, the technology is there already, but the price for renewable hydrogen is not competitive with the grey hydrogen, and this is just highly affected. So the green hydrogen we get if we turn on the electrolyzer, that is splitting water with the electricity. So it is really important what kind of electricity goes in, so we can also plug the electrolyzer just to a grid. But if there is no green energy in the grid, although the hydrogen is produced via electrolysis, it's still not green hydrogen. So we need the green energy, and it also needs to be with the reasonable price that it can compete with the grey hydrogen.
Andrus and Ragle, you both mentioned hydrogen. When discussing hydrogen, everybody has their own opinion. Is it already here? Is it just around the corner? Or is it several years ahead? What do you guys think?
Yeah, if I may add, so actually hydrogen isn't anything new. I mean, it has been already used like more than 100 years to make ammonia for the fertilizers. So, and as I also showed in the slide, like almost 100 million tons of hydrogen is already been used in the world. So actually the production, transport, storing, handling hydrogen, it's already here. Of course, what makes it maybe new is for the energy sector. If they are considering hydrogen, this is rather new. And by bringing it for everyday life for people, of course, this is then something completely new. And there are specific rules that needs to be followed. And of course, this is dangerous like all the other fuels as well. So we need to follow the guidelines, of course.
Before I give the floor to Andrus, I want to tell again to you that I'm expecting some questions. Maybe after a minute, Andrus, Terje can warm up the microphone already. And Andrus, what do you think about?
Yeah, as Ragle mentioned, so hydrogen has been used more than 100 years already. So there's definitely nothing new. So I would say currently the issue is to get the green hydrogen with the right price, because the technology also for the green hydrogen, everything is there.
Sure, I agree. Coming from chemical background,
and scaling it, and it's possible to scale very easily. So
very good. I now understand why people come to the stage and are blinded by the lights. Half of the people I don't see, but Terje definitely will see whose hand is raised and give the microphone there.
No hurry.
Yeah, hello, Hardy from Steiger Engineering. Continuing with the topic of hydrogen, so the question to the panelist is, what needs to be done to get the green hydrogen price down? Is there some technological updates needed? Is it just a question of scaling up the production to get the unit prices down? So what would be needed? What steps would be needed to get the green hydrogen price competitive with the grey one? And the second part, since as I'm a geologist, and my question is, have you, while being in the hydrogen business, have you been thinking about natural hydrogen as well? Because I know my colleagues in Europe, in Australia, they are thinking heavily about the exploration and extraction of natural hydrogen as well. And how would that change the picture?
Good question. Whoever wants to start.
Yeah. Okay, yes, I can start. Yeah, so to get the green hydrogen, I mean, things would be much easier if this really happens. The 2030, the grid is green. That means that we don't need to have the direct connection from the electrolyzer to a wind park, but we can just plug in the electrolyzers to the grid because the grid is green. Now, yes, the question is how we can get this grid green, and maybe I think here the wind energy specialists have maybe more idea what steps need to be done to get the grid green by then.
Very simple, build more wind turbines.
That's what the conference is about, right?
Yeah, but jokes aside on the green hydrogen, if we want it to work, it needs to make economical sense at first. So we need to have cheap, abundant electricity. To have this one, we need to build more assets, but who will build assets if the electricity is cheap and abundant? So that's a very big question for me. I would say it will take, to roll up hydrogen economy, I would say at least 10 years. We will wait to see this in action. It's my personal view, of course. Other point to add here, I think really there is very hard to come to the market, Estonia or Latvia or Lithuania, and to build something from scratch. You need to build your own renewable assets before going into the market, into the hydrogen production. You will need to see the other market players like Ignit is doing in Lithuania, some plans for the power-to-X and hydrogen solutions. Then we have European Energy working in Lithuania. Recently it was announced that they are investigating now the possibilities of building methanol facility in Lithuania, e-methanol facility. But this not happens, from scratch. They are building in the market some renewable assets, looking how they can back up this e-methanol facility in the future. So all this needs to, make sense, economical sense. So I think that's really important. And for now to compete with the gray hydrogen, when we have the gas prices in between 30 to 40 euros, so the rule of thumb from my side, you need to see electricity prices at least on the same level as the gas prices to get the break even.
Sorry, if I may actually continue here with
sure, of course.
Sorry, Terje. Yes, regarding having the green grid and connecting the electrolyzer to the grid, of course, electrolyzer is a huge consumer. So, and we also need to talk about, in this case, well, in general, about renewable energy, we need to talk about grid stabilization. So, and of course, the electrolyzer is a big consumer, so it would make, of course, sense to connect it or turn it on if we have this excess energy. So, for example, in the summertime, if there is excess PV energy and we are not consuming it, we can turn on the electrolyzer, which is then consuming all this extra energy. And for the peak hours, for example, we can use this hydrogen and convert it back to electricity, whether it's then via fuel cell. However, this is currently a little bit expensive technology, but other alternative will be then the gas turbine. That for the peak hours, then you use this hydrogen that you have converted, you use it in the gas turbines. So this is so hydrogen is actually one possibility that helps you to stabilize grid. And the difference with the batteries is that batteries for quite a short time, but hydrogen actually allows you energy storage for a longer time. Of course, the ideal would be to pump the hydro, but not all the countries have this luxury. So hydrogen is actually another possibility to store energy for a seasonal period as well.
That's a great point. I wanted to come back to this point, but maybe we will have a few more questions from the audience and continue with you.
I have a question to panel. When we could see the real innovation in putting together wind energy and hydrogen generation on the top of wind mast? So, in principle, it means that we are going to transport molecules, not electrons, and it's mostly 8 to 10 times cheaper. No copper needed, maybe more of plast or aluminium, but no copper any longer. So, what's your expectation? What's your forecasts? Thanks.
So, Mendagas, you represented InnaCell, but
No, it's actually
HNSL.
it's actually the first time I hear the idea of transforming electricity to hydrogen directly at the wind turbine. Very nice idea. But so far as I'm informed, we are currently not investigating such an option. Since there are many technologies that you can just build together at the same place, doesn't matter if it's the up nacelle or on the ground, that's first. And for that to work in general, we need to establish the transportation networks, the grids for hydrogen, so they can reach the consumer whenever they need. Currently, the most prominent consumer in Europe is Germany, which will have which will need more that they can produce by themselves. But then if we are speaking about building grids, there are some plans. I know that there is a feasibility study being performed by the grid operators, gas grid operators, from Finland to Lithuania and then to Germany. But you all understand that such a project needs a lot of time. Of course, when those are in place, then really maybe it makes sense to transform the energy to the hydrogen gas and then to transport it whenever we need. Currently, that's rather challenging. It will take, again, as I mentioned before, I would say like 10 years or so to see this in action.
Other people were also noting, do you agree or do you see it from another light as well?
Well, I haven't heard yes about producing hydrogen on top of the wind turbine, but there are various projects going on where the offshore wind park and you have there a floating electrolyzer, so you don't have this long cable to the mainland, but you convert this wind energy offshore, you convert it to the hydrogen and then you transport it to the mainland. However, actually in the ideal world, you should actually produce hydrogen where you have a hydrogen off-taker. So
Sure.
This is the most efficient way. And this is actually why it is important to have the grid green, so that you can plug in the electrolyzer everywhere and not to bring it there where the wind farm is, because usually the wind farm is actually far away from the hydrogen off-taker. So we lose actually a lot with this transportation.
Great. Is there any other questions coming from? Yes, there is from the front row.
Hello, is it working? Yeah, I'm Kadri and I'm asking it as Estonian taxpayer. Jonas, you mentioned that Finland is having really great vision and yeah, they have even called that offshore wind energy is their new Nokia. Who should build the Estonian vision and from where it should be coming? And also the other question is that in the discussions, I think at the moment we only speak about this taxpayers, money cost for taxpayers, and there is completely absent this values for Estonia. If you build all those wind parks offshore as well, so who should coordinate it, who should build it, and who should market it? So how to make it happen? Maybe also for new renewable energy association.
Oh, okay.
Good question. Society on its own, all should actually make its input to actually to find out the actual way. But of course, who are those associations? I mean. Different messages from the society need to find its way to the politicians, of course, and that these associations and then who gather the companies and the different citizens are the stepping stone for that. But it's I think. We don't need to find, it's not a witch hunt who hasn't done it or who needs to do it. I think we need to, through the society's discussion, we need to understand what are actually the sectors, because it's unfair for the government for actually to say that I don't know, this is the main priority because there are different economical sectors in the country. But of course we can nudge some of those sectors who the country sees for the future economy.
Kadri, yes, thank you for giving something on my plate. But I wanted to follow up on Ragle's idea you shared a few minutes ago. I hope many of you remember what Lauri Ulm yesterday morning. It was one of the first presentations he had about when the renewable energy 100% target is reached. Then, of course, there will be several hours that wind energy is produced more than we currently, or at this moment, demand. And there are hours that the graph is lower than the demand graph. So, Ragnar, you already mentioned about the possibilities to balance out.
Yes.
Do you have anything to add on that? Or?
Yeah, so if we talk about using an electrolyzer to produce hydrogen for the grid stabilization, it is also really important this smart energy management system. So this all needs to be like automated and controlled. So currently we have this day ahead electricity price prediction and also how much is then produced. So all this information needs to be taken into account and really plan when the electrolyzer will be turned on and when it will be turned off, whether it's a gas turbine or whether it's a fuel cell will be turned on and turned off. So yeah, this I can add.
Andrus, from your slides, I saw that there's a great possibility to balance the grid with these technical solutions that are soon to be seen in Veo electric or energy complex.
Yes, indeed. First of all, I have to add that actually 2030 target is to cover the consumption, so the annual consumption. So 100% of the annual consumption should be covered. So energy consumption should be covered. We don't have to full every second the load with the renewable electricity. So, but yeah, definitely in Veo, yeah, let's say for example the heat storage can work as a how to say as a power consumer. So when there is excess electricity in the grid, so it can consume. So then there are different stages or different levels how you can turn on the loads there. So that it can work. It can supplement the grid. Also, it can work as a automatic reserve because the switching on the heating, electrical heating, it's just a matter of seconds. So
I agree. From my side, I definitely see that these kind of technical solutions that provide these kind of balancing or stability measures, these are crucial. I wanted to also ask from Jonas that is it something that also industries look at as well, or how to balance, or how can they be, let's say, not 24/7 working, but also be working together with the whole system to be also demand responsive. Is it something you see in the market as well or not?
Not really. I mean, we saw the Enercon, Estonian company, who managed absolutely on their own with French company to finance the project in Estonia. So that's not in our scope right now. But of course, the possibility from the private sector to have the ask for us that we actually need foreign investors for that kind of projects, and of course we're open to look into the project, because we actually on this year the Estonian Investment Agency will be 30 years old. So during that 30 years, there has built quite a network of foreign investors. So we could have those connections be made for the consortiums of Estonian company and any others to actually realize the projects in Estonia.
Thanks. We have a couple of minutes left, so for my very last question, I wanted to ask one thing that you will take from this conference at home or to your colleagues, and one other thing that you would really want to stress again or give to others to take away from this conference. But before you get the opportunity to share your thoughts, maybe let's take 1 or 2 short questions from the audience if we have any. Yes, there is one hand at least, I see.
Hi, my name is Holger. One question again to Jonas. If I remember correctly, you showed possible investments here which would require, was it 8 terawatt hours of green energy? What do you tell those investors? Because apparently there are no plans to really develop them. We've heard from Elring, they have much lower plans than your own expectations, and we don't see any more investments in the grid than that.
Mm-hmm. Again, good question.
First of all, we say that you're welcome into Estonia. But of course, as I showed the sales funnel or the client funnel as well, that we do understand that all of those projects will not realize in Estonia. Maybe at all, maybe not at all. So we, of course, we try to give the quite a realistic overview of the energy topics and the energy sector in Estonia as well. And like I said, there are long lists and short lists. Most of the projects which will come onto our table will not realize, and then maybe they will not find a home in Europe at all, or going to any other countries. But as we have discussed here as well, probably the consumption will rise quicker than planned. As we see already from the wind energy production, then the plants with PVs are like 10 terawatts. We still have the connections with other countries as well, electrical like the grid connections, and we still have fossil fuel energy as well. So I think that the phasing out will be not that like dramatic, or not that like on the next day, yes, we're now green. So it will phase out, slightly. But all in all, Elering says that actually the grid could take in way more than actually it's possible right now. And I think those other renewable energy productions will in the near future come into the grid or into the Estonian like energy sector. So I'm more optimistic than most of people, maybe a little bit naively, but it has helped me in my life until this far.
Yeah, I sometimes share your positivity and naivety myself. But very shortly, these 2 questions I asked, maybe something you would like to share and something you would take away from this conference. Maybe Ragla, ladies first.
Yeah, so something to take away, if I need to keep it really short because time is up. So one fact, and this is about this 170 decibel noise limitation and 750 meters radius from if you install the wind turbine offshore.
Good memory.
This fact, yeah.
What's the one thing you would like to share with others as well? You have anything?
Well, this I have to. I mean, I did this 20-minute presentation. There was something.
Okay, yeah. This everyone can download it later as well, I think. Yes, let's go, Andrus, maybe.
Yeah, it's something to remember. I think the morning panel, and I have to thank very much for the organizers, Terje, Kadri, Margot, the Dutch embassy, and bringing lots of guests also outside from Estonia and from Netherlands here. So I think it's a really good possibility to exchange or to learn from the countries which have basically gone through the process already and then made their mistakes. So let's say the wise people, they learn from the mistakes the others are doing. So let's try to avoid making mistakes ourselves. So
great to see that you're a wise person then.
I try at least. And then to share is I hope really that this conference made our state or the state officials to dream bigger and to have their vision, to put their vision and ambitions, to set their vision and ambitions.
Great. Mindaugas.
My key takeaway is basically that this not only applies to Estonia, but all three Baltic markets, is that we still lack of some of the market mechanisms, which will really help to grow and to reach the renewable targets. And I'm talking here about the offtake solutions, of course. So since we have here some government bodies, they should listen to this and think slowly, but work on this topic, either to foster the corporate PPA markets or implementing CFD mechanisms. And also the idea I heard yesterday, I really liked it, that CFD is not like a subsidy scheme, it's more like an insurance to get the sector rolling.
Sure. Jonas, your final words.
Final words. I think the one thing I took from the conference is that, as I said, I'm optimistic, but I heard from the stakeholders in the private sector and also from the public sector that actually we have developed already into the right direction even more with the last couple of years. So I'm positive on that. And on the second, maybe it's even more of a message is that it's difficult. There are definitely risks, and then the sums and amounts of money being invested into the wind parks or into the industries coming out of that. They're huge and there are risks. I think that the outcome could be that the private sector and us as well, we have the overview of some of the outtakers. So we definitely need to communicate more with the developers that we should delete the calculation from that, delete that number from that calculation that there needs to be an egg or a chicken first. We need to move at the same time that we have the plan, we have the vision, we start moving step by step, and we also have the potential outtakers on the side.
Dear audience, I think that tonight's panelists deserve a huge applause, and I thank you as well.
And I thank the moderator. Someone needs to thank the moderator too. Good job, Michael. So good news is that Estonia has clear goals for 2030, but as was highlighted by several speakers throughout several panels, strategic vision perhaps need a bit of clarification post 2030, especially keeping in mind the potential of offshore wind energy. It would be wonderful if we saw something similar in Estonia in its strategic vision, as we know from the Netherlands, with clear goals of energy development by 2040 and 2050. Because it's quite clear that there's huge potential in wind energy, coupled by also a great potential to increase electricity consumption in Estonia, which we could easily double if we look at the example of Finland. Now, to get there, we obviously need to fill quite a few gaps. Grid, permitting and auctions were all passionate topics throughout the 2 days. And although there is good progress made, I think we can also acknowledge that. We have plans that are being renewed. There are still glitches in the process that need attention, and you all know where they are located. So the market is eagerly waiting for long-term vision. both in the grid and in de-risking, because yesterday we heard a brutally detailed overview from financial institutions about conditions that a bankable project has to comply with. And I guess that sends quite a clear signal that wind development, although it has huge potential and opportunities, also has significant risks that need managing, especially in a tiny country like Estonia. But again, the potentially added value to the economy and society that we heard in our last panel is clear, it's there. Economic growth, it's very hard to imagine without green energy. And I mean, growth is something I guess we would all like to see in Estonia, especially 2 years after an economic decline. Thank you all, the sponsors. Without you, this event would not have been possible. Thank you to the Dutch Embassy for, again, bringing a great delegation of experts. Hopefully there was a few deals made yesterday and today. And because it's Valentine's Day, and we obviously wish to leave the smallest footprint possible, you see a bicycle covered with flowers, and this monitor here also surrounded by wonderful flowers. You are very welcome to take a few with you. I plan to pick up a few flowers if you don't tell my girlfriend that I got them from work. It was wonderful spending those 2 days with you. I got a lot of inspiration to take with me from here. I hope you can say the same. See you next time. We have a new moderator taking the floor now.
Hello. So let's continue the session with the discussions about the future. But actually, we have to give a round of applause to Terje organizing the event, sleepless nights. So hopefully it's not the last time and she will find the energy to do it again. So please, your round of applause.
I was hoping that I will skip this part, but still, thank you all. It's me and my 200 closest friends for Valentine's Day. So thank you, and I really hope that it was successful and we can continue in the good way. So thank you and happy Valentine's Day, and please bring your flowers and we don't tell your boyfriends or girlfriends where you got it.